Hello, and welcome to the exam AZ-104 Microsoft Azure Administrator course. This course is designed to help you prepare for the AZ-104 Azure Administrator exam. Passing that exam makes you Microsoft certified as an Azure Administrator Associate. This course focuses on creating and configuring common services in Azure that are related to compute, networking, storage, and security. In addition to an overview of each service, I include demonstrations of setting up and configuring the service in the Azure portal. Some background in IT administration is recommended for success in this course. If possible, set up a free Azure account at azure.microsoft.com. Your exam will most likely include some questions in the Azure portal to test your implementation skills, and your hands-on experience will serve you well. This course is divided into 11 lessons. Each lesson is broken down into sub-lessons covering skills relevant to your exam. In lessons 1 and 2, we explore Azure Active Directory, tools to govern your Azure subscription, and how to secure resources. Lesson 3 is about using Azure Storage for your file data in the cloud. Lessons 4 and 5 cover Azure App Service for platform web deployment, as well as services for Docker container deployments. In lessons 6 and 7, we explore setting up Azure VMs, virtual networks, and connecting VMs to on-prem resources. Lesson 8 is about protecting and replicating VMs through backup and site recovery. Lessons 9 and 10 cover common networking services for VMs, including load balancing, hostname resolution, and firewall protection. We finished with Lesson 11 on monitoring your Azure environment. There's a lot to cover, so let's get started. Welcome to Lesson 1, Manage Azure Active Directory Objects. In this lesson, we learn about identity management in Azure using Azure Active Directory. We discuss how to manage user, guest, and group accounts, perform bulk updates for users, manage users' devices in Azure AD, and how to configure self-service password reset so users can change their password in the cloud. Let's begin with an overview of Azure Active Directory. Azure AD is a multi-tenant directory, so all customers or tenants are in one huge directory that Microsoft manages. However, your tenant is private to you. Azure AD is primarily an identity management directory, so it's mostly used for user login authentication. User IDs and passwords are validated against information that Azure AD stores, and then users can be given permissions to resources. Azure AD is a trusted provider, so that means it speaks the modern internet security protocols like OpenID, OAuth, and SAML, and this helps simplify single sign-on for cloud-based applications. Many companies will synchronize their on-prem Active Directory, ADDS, into Azure AD. And that process helps you leverage all the user accounts you already have in an on-prem environment. Before you add users to Azure AD, it's a great idea to first set up your custom domains. So a custom domain is any domain that you own that you want user ID suffixes to end in. So you must prove that you own the domain by going to the DNS zone for that domain and adding an entry. Let me show you what that process looks like in the portal. So here I am in my Azure Active Directory. If I scroll down on the left to custom domain names, you can see that I have one domain by default. This is the one that was created when my tenant was set up. So default tenants always end in onmicrosoft.com. I'm going to add a custom domain. And if I own the domain acmeparts.com, I can add that here. I must then go to the DNS zone for acmeparts.com and add this TXT record that's listed right here. Once I do that, I can click Verify here, and Azure AD will let me use that domain. Obviously, I don't own that domain, so that didn't work, but I can go back to look at my custom domains, and you can see that this is waiting to be verified. So it's an important step to do this, and I'll show you what I did in my own private domain. So I own buckscreek.com. When I verified that domain in my Azure AD tenant, I am then allowed to use that as a suffix for usernames that I create in Azure AD. So it's important to set up custom domains before you begin adding users in. Let's talk about the process of adding user accounts in Azure AD. So there's actually two types. One is called strictly a user account. That's typically for employees. These are people that will have a domain suffix from one of your custom domains. So their user ID will likely match something they already have on-prem and that they know as their logon ID. A guest account can be used for non-employees that need permissions in your directory. They can have any email address you want. They're actually sent an email invitation. You can then assign them to any security role, and they have those permissions in your directory. Let me show you how to set up a user account. So in my Azure Active Directory, I can go to Users, add a new user. So Create User allows me to type a username. Notice my domain suffix, the only one allowed, is the only one that's been verified for my domain. The only other required field here is a name. By default, Azure AD generates a password. You probably want to note this password somewhere because you can't see it later. You could just pass this information on to the user. And now Sue Blue is a user in my Azure Active Directory. Sue doesn't have any other permissions yet, but she's a user in my account, in my Azure AD, and I can come and assign roles to her, put her in groups, and so forth. To add a guest, it's the same process. You just click on the users, the Add a Guest link under Users, and then type in the information, including an email address, and that person will be sent an invitation to log on or accept the invitation to be a member of Azure AD. Next, let's talk about groups. So groups, just like in Windows, are ways that you can organize users by department, job title, whatever the groupings are that you need. And then you can leverage that when you start assigning permissions because you can assign permissions for groups instead of users. When you set up a group, there are two types to know about. There are security groups and Microsoft 365 groups. Typically for Azure AD, you're going to be using security groups because those are the ones that you can use to assign roles and permissions. Microsoft 365 groups are used for features in Microsoft 365, like SharePoint collections, shared mailboxes and calendars, and so forth. So let's look at the process for setting up a group. Back in the portal, list groups. I have one group here called Sales. I'll add a new group. It's a security group, the name of the group, research, add a description if you like. Membership type, we're going to do assigned first. So an assigned group means you're going to select members. And if you wanted Sue to be in that group, find Sue and select. Now all groups have an owner as well. By default, it's the person who creates the group, but the owner is the person who can change the membership of the group. I'll create the group. And now I have a new group. Let's refresh. And hasn't shown up in my list yet. There it is. Now, before we conclude our discussion of groups, let's also talk about dynamic groups. So the assigned group is the one I showed you. An assigned group is one where you specifically add users and other groups, possibly, to group membership. A dynamic group allows the membership to change dynamically. There's two types, dynamic user and dynamic device. We'll talk first about dynamic user. So it does require a paid tier of Azure Active Directory called Premium P1. Membership can automatically be assigned based on some attributes in the user object, such as department. There's a department attribute, and if you set the department, you could have a dynamically assigned group that was based on that department name. You can do the same for devices, and we'll talk about devices later in this lesson. The nice thing about dynamic groups is if the attributes change for the user object, the group membership automatically changes. So if you move a user to a different department or give them a different job title, then their group memberships would change automatically. That makes it much easier to manage. I'll show you the rules engine in a moment for this, but you can construct rules that look at more than one attribute. In fact, up to 5 different attributes for determining group membership. So let's see how it is that we do that to set up a dynamic user group in Azure AD. I'll switch back to the portal. I'm going to do a new group, still a security group. I'll call this my R&D group, and I want the membership to be dynamic user. So I need to add a dynamic query. For dynamic query, you can choose, since it's a user, you choose properties from the user object, such as department. And you could say contains, maybe the word research. You could add another expression. And maybe the department for some of our people contains the value R&D. I would want to switch this to an OR so that the query effectively means if the user department contains the word research or contains R&D, then this user should be in the new dynamic group that I'm creating. I'll click Save here. There's my dynamic query representation. There's the name of my Azure AD group, and now I can create the group. So I've showed you the process for adding users and groups manually in Azure AD. If you're going to synchronize with your on-prem AD, then you would not add these in this way. You would set up your custom domains, but then you would import the user accounts and groups from your on-prem AD. Let me click refresh here and see if my group, there's my new dynamic security group. If you're not going to integrate with on-prem Active Directory, but you still have a lot of users you want to add, you may want to look into the bulk user operations available. So there are bulk creates for user accounts. You just download a CSV template file from the portal, fill out the CSV file, and then you can upload it back to the portal. In addition to creating users this way, you can also invite guests, delete users, and download a list of users to a CSV file. For group accounts, you can do some of the same operations. You can import groups, remove groups, and download the members in a group. However, there is no bulk create for groups. Let me show you how this looks in the portal. So I'm here in Azure Active Directory. Here's under all users. You can see bulk operations listed here. I'll do a bulk create. Download the template file first. And then I'll fill this file out. You should not edit the first or second row of this file, but you can fill out new users starting on row 3. The required columns are indicated, so display name, username, and an initial password. I'll leave that. And then should the sign-in be blocked or not? I'll set that as no. The other fields are optional, so I'll leave those blank. And now this file can be saved and uploaded to the portal. I'm back in the portal now. I selected the CSV file that I created. It has been uploaded but not imported yet. So I click Submit, and the Azure portal will process this file and give me information when it's finished. If you like, you can click the link here to view the status. Looks like it just finished right there. Completed with no errors. Joe Smith was added. I can go back to my users, all users, and there's Joe. For groups, let's go back to the top level of the directory, go to groups. Notice there is no choice here for bulk operations. Instead, you go into the group that you want to modify, such as sales, go to members, and then here's the bulk operations. So you can import, remove, or download the members of a group. So you'd have to create the groups in Azure AD first, and then you can add the users as necessary. So that's it for how to do bulk operations for users and groups in Azure Active Directory. In addition to users and groups in Azure AD, you can also track devices. So a device is a computer, like a mobile, tablet, or a PC, which a user uses to authenticate to Azure AD. You don't add these devices, but you can manage them in Azure AD. You can see the operating system that's being used and version. You can see what's called a join type, which we'll talk about shortly. And you can enable and disable these devices. Let me show you in the portal what this looks like. So in my Azure Active Directory, if I go down to Devices and click on All Devices, I don't have any listed here because I haven't used any devices to connect to this particular tenant, but you can see the menu choices here at the top include Enable, Disable, and Delete. These are nice ways to be able to manage the device. You might want to disable the device, for example, if it's a phone and somebody notifies you that they've lost their phone. So disabling that device would prevent the login to Azure AD from that device. You can also see device settings here, and device settings take us to information about the join type. So let's talk about join types now. So there's 3 join types for devices in Azure AD: registered, joined, and hybrid joined. And these are good to be able to sort differences for your exam. So a registered device can be Windows 10, iOS, Android, or Mac OS. Those are the allowed operating systems. Registered is sort of the first level of join type, and potentially any device that logs into Azure AD will show up as registered in Azure AD. The device itself can be owned by the user. It could be owned by your organization. It is possible to do single sign-on from these devices, but only single sign-on to the cloud, which means single sign-on to Azure AD itself. In the picture you can see here, like a bring your own laptop or a mobile device, could both fall in these categories as being able to authenticate into Azure AD and therefore be registered. A join device type is Windows 10 or Windows 11, but not the Home Edition. So already there's quite a restriction here where you're not allowed to use iOS, Android, Mac, anything but Windows 10. It's assumed to be an org-owned device. The SSO can happen to Azure AD as shown in the picture. Could also happen to on-prem Active Directory, but through Azure AD. So notice there's one line here that goes from the org-owned laptop to Azure AD. So the authentication happens there, Azure AD may communicate with your on-prem Active Directory to finish the authorization or authentication, but that Windows 10 is the only OS that can be joined. Now, hybrid joined is just a modification of that. So this is for not only Windows 10 or 11, but also for the so-called down-level clients. So if you're running Windows 8.1 or Windows 7, these devices also are organization-owned, and they can do SSO to Azure AD. They can also talk to your Active Directory domain services on premises. So it could be a laptop in the office, something like that. So hybrid joined has this notion of being able to authenticate to either directory, either Azure AD in the cloud or your on-prem AD. Let's talk about some scenarios for this. For a registered device, maybe a consultant that needs access to resources. And so it's a computer they own. It's not a computer that your organization owns. So the consultant could have a registered device. Perhaps a user accesses email from a personal phone. For joined devices, this could be used for organizations that don't have an on-prem Active Directory. And so hybrid joined is not a choice in that case. And so the authentication could happen to Azure AD. Often these are used for organizations that don't synchronize with on-prem AD, but they do have Microsoft 365. Hybrid joined devices, probably the primary use for this would be the down-level client. So they don't have Windows 10, they're running Windows 8.1 or 7 on the desktop, but you may still want to control or manage the device, allow synchronization or authorization against both. And so hybrid join could be your choice for that. Another reason you might do hybrid join devices is because you have Windows AD group policy and you want to be able to apply that to those down-level devices. Here's finally a flowchart that summarizes this information. Let's just notice that to get to registered, how you get down here in the lower left corner is you're on something like iOS, macOS, or Android, right? So those devices, since it's not running Windows, there's limit choices. You can't do either of the join types. You have to use a registered. Interesting to note under this no option here for no Azure AD options could be a Linux OS. So in order to get to hybrid Azure AD join, perhaps it's a down-level device. So it's Windows, but it's not Windows 10. You can also get there if it is Windows 10, but it's domain joined, and the worker is not remote, then you could still end up with Azure AD join. To get to Azure AD join itself without the hybrid part, it is Windows 10, it's not domain joined, you don't have any group policy requirements, you could choose to use Azure AD join. So for test purposes, I would focus mostly on the kind of device it is in a way that might control which kind of join type you could use. Self-service password reset is the ability of users to be able to change their password in the cloud. So on a login screen for, say, Microsoft 365 or perhaps the Azure portal, if the user needs to change their password or they're forced to change their password, they can do it through some web pages. It's important to note this is an Azure AD Premium P1 feature and above, so P1 or P2. So at the free tier, this is not available. When you enable it, which I'll show you how to do in the portal in just a moment, you can enable it for all or specific groups of people. You can indicate which kinds of identification are required in order to change the password. So you don't want anybody to be able to change the password from a web page unless They can prove their identity through an email or a mobile phone, like a text message, or through a set of security questions. Once you turn this on for users, they'll have to register some contact info so that Azure AD has their mobile phone, has the answers to their security questions, or depending on how you can set it up. If you do integrate with on-prem Active Directory, there's an important change that needs to be made in Azure AD Connect, and that's what's known as password write-back. Normally, Azure AD Connect does not write into your on-prem Active Directory, but think through this. If a user changes a password out in the cloud, we do want that password written back into Azure, into the on-prem Active Directory, so that the user's password is the same in both places. Once that is turned on for Azure AD Connect, you can enable or disable it through SSPR settings in the Azure portal. Some organizations choose not to configure self-service password reset for this very reason, because they don't want Azure AD writing back into their on-prem directory. But that's a decision an organization can make. Let me show you in the portal how you could set this up. So first to note here in my Azure Active Directory is that my license is not Azure AD free, it's Premium P2. If you set up an Azure AD tenant, you can enable Premium free for 1 month. So if you're testing things out in the portal, you can try this yourself as well. I'll scroll down to password reset and notice that none is what's selected currently. If I want this enabled, I can turn it on for specific groups or for all groups. If I turn it on for specific groups, I can pick a group and you save this setting. And then you go to other blades to configure. So authentication methods, how many methods are going to be required in order to reset a password? Your choices are 1 or 2. And then these are the available methods the user could use. Commonly done things are mobile app code, mobile phone or email, perhaps an office phone if you have those stored for all users. If you enable security questions, you must specify how many questions the user will be required when they first register their info, and then how many questions will they be required to answer when they want to reset their password. And so selecting questions is a process of just picking. There's several predefined questions. You could choose many of these. Add your own custom questions if you like. When you get this all ready, you can save your changes. Other settings here that you might want to look into. For registration, typically you would require users to register the next time they sign in after you set up SSPR, and then you can ask them to reconfirm their authentication on a schedule. Default is every 6 months. You can be notified. Do you want to notify users when their password is reset? That could be a nice security feature in case someone didn't actually authorize the password change. And then whether or not you want all admins to be notified when any admin resets a password. That could be a nice security thing to turn on as well. Under customization, you can specify your own help desk link. So if users having trouble resetting the password, they could perhaps contact a company portal or send an email. And then under on-premises integration, this is where you can enable or disable password write-back. It has to be turned on in Azure AD Connect, but then you could temporarily stop it here or enable it here as needed. So we're at the end of this lesson. Let's wrap up, talk about some of the things we've learned. We first looked at Azure AD users and groups, how to add them in the portal manually using portal pages, also how to do bulk operations. So getting a CSV template file, adding the rows to the file, and then uploading those directly into the portal. We looked at Azure AD devices, registered devices, joined, and hybrid joined. you should keep in mind the kinds of operating systems that are supported by each so that you can understand and answer questions about what kind of join type would be appropriate given a client operating system. We looked at a feature of Azure AD called Self-Service Password Reset, which allows users to change their passwords in the cloud. It does have effects for on-prem AD synchronization, as we discussed in Password Writeback. Finally, I want to say a word about command line information. You will likely see a few questions on your exam that require you to recognize a correct version of a PowerShell or an Azure CLI command. And so what I will do at the end of each lesson is take you through some example commands to give you a flavor of how these commands work. If you're new to PowerShell or the CLI, you'll get the hang of it fairly quickly, I think. So to do that, I'm going to switch to the browser, open up a new page. The best thing to do to study for this is to go to docs.microsoft.com. This is the documentation site for all of Microsoft products. If you scroll down, you'll see Azure here. So from here, below all the information about the services, you'll find languages and tools. And we're going to spend a little time looking at Azure PowerShell and Azure CLI. So I'm going to open CLI in a new tab. I'll open PowerShell here. There's information here about how to install PowerShell and how to get it working and so forth. I want to focus down in the reference section. So down in reference, if you scroll down, you can quickly see dozens, many dozens of choices just based on the kind of feature you want to work with. Let's go look at Active Directory. So under Active Directory, you'll find a list of all the commands that relate to Active Directory in PowerShell. So PowerShell commands always begin with a verb, add or get or new, remove, sometimes delete, update. So that's one clue as to the kind of command you would need to understand. Let's scroll down to new AZ-AD user. Oh, another thing I'd like to point out too is all Azure PowerShell commands have the letters AZ after the dash. So new AZ-AD user creates a new Active Directory user. You don't really need to memorize all the properties for these, but if you get a flavor for what they're asking, I think you'll be able to recognize what you see on a test question. So here's a new AZ-AD user, setting the display name, setting the user principal name, which is the login ID, and setting a password. So that's one example. There's also a new AZ-AD group. So AZ-AD groups, a group needs a display name, possibly a male nickname. How do you add members to a group? That's get AZ. Let's scroll up. Add AZ-AD group member. So we're adding a member to a group. I'll scroll down to an example. Here we're adding group member by object ID. This one's a little friendlier. Pipes it, well, that's by member object ID. Here's the friendly one, add AZ-AD group member, member user principal name, and then target group display name. So I recommend that you spend a little time in the documentation for a given section or lesson in our course. Go and look up PowerShell commands and just scan them. You don't need to memorize all of the choices, but once you get accustomed to the verbs that are used for the action you're trying to take, and you understand some of the terminology that Azure AD uses, then I think you'll be able to answer those questions. Let's talk about the Azure CLI. So this is another command line you can use to access Azure. PowerShell works traditionally on Windows. The CLI can also be installed on Linux and Mac OS machines. So the structure of the CLI command is different. So whereas PowerShell starts with a verb, a dash, AZ, and then whatever the command is, you'll find in CLI that you always start with AZ. So that takes you into Azure. And then following that is the feature or the service you want to work with. So AZ space AD gets us into a hierarchy that allows us to work with the AD portion of the CLI. So I would expect to find something down here about users. I'll keep scrolling. Here's AZ AD user. And in fact, there's AZ AD user create, AZ AD user delete. So you see the hierarchical nature of the CLI commands, I think make it fairly readable and easy to understand. If you go into AZ AD user, you can see that many of the property names are the same as you would find in the PowerShell command as well. So if you're not a CLI person, doesn't matter, I don't think. If you find a question on the test like this, I think it'll be fairly straightforward what module you're using once you understand the abbreviations, and then what feature of that module you're using, and then usually a verb towards the end that tells you what it is you're going to do with that item. Welcome to Lesson 2, Manage Subscriptions and Governance. In this lesson, we learn how to manage a resource hierarchy in Azure, how to secure resources using role-based access control, and how to lock and tag resources. We also discuss ways to manage costs in your Azure subscription and a service called Azure Policy for assessing and enforcing organizational standards. In this lesson, we want to understand the hierarchy that resources are a part of in Azure. So what's a resource? A resource is just something you create in the portal or using PowerShell or the CLI, something like a virtual machine, a storage account, or a database. So it's anything that you create in order to store your data or run your code. Resources belong to exactly one resource group. A resource group is simply a logical collection of resources. I say logical because it doesn't have anything to do with where they're located in Azure, as in which region. They can be from any region, but it's a way that you can organize, in fact, a way that you must organize your resources. This plays into security, which we'll discuss later in this lesson. A subscription is the level above resource groups, and a resource group must belong to a subscription. The subscription is where the billing occurs, so all the resources inside a subscription, they roll up into a single invoice once a month for your subscription. There's one other level above that called management groups. So a management group is simply a hierarchy of subscriptions. It allows you to group subscriptions together. You can have them at multiple levels of management groups. So for very large organizations, that can be a nice way to manage that. Let me switch over to the portal and show you. Before I show you the details about this storage account, let me just show you when you create any resource in Azure, typically the first two things you must specify are a subscription and a resource group. So this is where you start establishing the hierarchy for the resource itself. Let me go back to the resource I created, a storage account. And you can see the resource group listed here. You can see the subscription listed as well. So this hierarchy is linked throughout the portal, and you can use that to your advantage as you're navigating and looking around. So if I click on the resource group, I can see all the resources that belong to that resource group and manage them as a group if I want to. On the menu, there's also just a list of all resource groups if you want to view things this way. So as we'll see later in this lesson, Permissions can play heavily into how you set up your resource groups. You can simplify security with the hierarchy that we mentioned, because permissions can be set at the resource level, at the resource group level, even at the subscription level and the management group level. And those permissions are inherited down the hierarchy. So a little bit of planning goes a long way. You want to set your permissions at the highest level possible so that maybe someone has permissions at the resource group level and therefore they can manage all the resources in that group. It is possible to move resources. We'll mention that later in this lesson, but it's best to plan ahead because it's just less work later. So we talked in the last lesson about how to create users and groups in Azure AD, and now we want to finish the discussion about how to assign users or groups permissions to access resources. This is done in Azure through what is known as role-based access control, or RBAC. And RBAC, in fact, authorizes every request to access resources, whether you're reading a resource to look at it in the portal or whether you're modifying a resource through the portal or PowerShell or any other way you can access Azure. So the process is to identify the users and groups, identify a role that you want, and roles are tied to resources, and then you assign the user or group to the role to allow access. There are 3 general roles that exist for every resource: owner, contributor, and reader. The owner can perform any change to the resource. So they also own it, and so the person who creates the resource owns it, so of course they can make any change they need to. The contributor role can perform any change except changing permissions. So they're similar to an owner. They can make any modification to the role or to the resource, but they cannot change who can access the resource. The reader, of course, can only read the resource, cannot modify it. There are many dozens of built-in roles in Azure, some of which are specific to resources. We'll see a list of those momentarily. You can also create your own custom roles. So if there's one in Azure that's not quite what you need, you can modify it, create a custom role, and then simplify your permissions. Let me show you how to do RBAC in the Azure portal. So I'm at my storage account here, and just about every resource in Azure has an access control blade. Access control is where you assign resource permissions and also where you look at role assignments. If I come and look at role assignments here for this storage account, you can see that I've already assigned Chris Green as a contributor for this resource. In fact, the scope of this is a resource group and it's inherited. So this is what I was mentioning before, that since all resources belong to a resource group, you can assign permissions at the resource group level, and it really simplifies permissioning. In fact, I'll go up to the resource group level to add a new permission. So at the resource group level, notice there's an access control here as well. Click Add, Role Assignment, and then choose the role. So if I want a user to be a reader of this storage account so they can look at the permissions of the storage account but not modify it, choose that role, and then choose the members. You can either assign roles by user or group. We'll talk about identities later. Under Select Members, maybe I want Sue to be a reader. I select Sue. I can review and assign. And now Sue is allowed to look at everything in this resource group. Other things you can do in the access control blade. Let me go back to the storage account, access control. If you're curious what access someone has to this resource, you can look them up. So here's Sue. And Sue has reader access. It's been inherited from the resource group. You can also see a summary of those role assignments as I showed you before. And here's the list of all the roles that are defined. So this is the list of roles defined for a storage account. You see owner, contributor, reader are the top three, and then there are others based on different kinds of resources. Like a backup contributor would need to be able to access a storage account in order to back up the data. And so everything that you see here is related to storage accounts. If I go up to a higher level, I can also see a list of roles that are appropriate for the resource group. Go back to access control. Here are a list of roles, and you can see, I won't scroll all the way through, but you see that there are many, many, many built-in roles relating to all the different roles defined for all the Azure resources you could create, because anything can be put inside of a resource group. Next, let's talk about how to create a custom role. So roles in Azure are stored as JSON files. And the syntax is fairly easy to understand once you hear what a few of the rules are. If you need to create a custom role, the thing to do is start with a role that's similar to what you want and modify it. There's an easy way to do that in the portal that I'll show you in just a moment. So you start with a similar role, you modify the permissions, then you can assign it to a scope. So a scope would either be like a resource group or a subscription, something like that. In the role file itself, there are what are known as management plane permissions. Those are sections called actions and not actions. So management plane is what administrators typically do. So actions are things that they are allowed to do, and the asterisk here means anything. And then not actions are things that this role is not allowed to do administratively. And so as we talked about contributor being similar or almost as much as owner, except what a contributor cannot do is change permissions. And so that's represented in actions by the fact that authorization, which is who can do something with this role, not allowed to write or delete authorizations on this resource. And so that's what prevents the contributor from modifying the list of people who can modify this resource. Under data plane permissions, those are sections that relate to what happens to the data inside a resource. So if it's a storage account, it could be the blobs or the files that are inside it. None are listed for contributor, and so contributor really has no permissions to necessarily access the contents of blobs that are in a storage account. And that can be appropriate in many situations. Let me show you how to create a custom role in the portal. So here I am at East RG Resource Group. I'm at the Access Control Blade looking at roles. And I know that the contributor permission or role, if I go and look at the JSON file for it, so contributor can do everything except modify authorization and elevate action for authorization. There's a few other permissions related to blueprints and things that we'll talk about later, but that's the basic idea for contributor. Now I'm going to close this and go back because I want to create a new contributor role that's also allowed to modify the contents of blobs. So I'm going to call this a blob manager. I want to clone the contributor role, and now I set permissions for this role. So here's the list that was cloned from contributor. And at this point, I could add others or exclude other permissions. I'm going to add permissions. You do need to know what's called the resource provider, or the thing in Azure that's providing these permissions. In our case, it's Microsoft.storage. So here's my storage account. Here's the list of all the actions that are possible with storage. Here's the data actions that are possible with storage. I'm going to scroll down towards the bottom. And I wanted Blob. So I want the ability to read blobs, write blobs, delete blobs. So I can add these data permissions to the list of what's allowed for this custom role. Notice the permission type here is listed as data action. After you fill out the permissions, you click Next, go to the assignable scopes. If I just want this assigned to East RG, I'm done. If I wanted to change the scope, I could add other scopes, maybe put it at a subscription level if I like. You can review the JSON and notice we'll see all the permissions we saw for contributor. There's actions, there's the not actions we had before. And then under data actions, we've added some additional permissions. Can review and create. And now I have a new role called Blob Manager, and I can use that role and assign users to it. I'm going to look for my role, Blob Manager, there it is. For the purposes of your exam, I would remember things like the syntax and layout of custom role in JSON syntax. So there's a permissions section that contains actions and not actions. Those are things administrators can do. Data actions and not data actions, things that someone can do to the data that might be inside a resource. Let's talk about a resource lock. A resource lock is a mechanism in Azure which helps prevent accidental modification or deletion of a resource. It's important to note that locks are used for safety and not security. So a read-only lock prevents changes. A delete lock prevents deletion. What do I mean by safety, not security? Well, you can add a lock to a resource to prevent it from being deleted, but if you have sufficient permissions, you can remove that lock and delete the resource. So what the lock does is just add an extra level that someone has to step around or remove in order to be able to either change or delete a resource. Locks are inherited down the resource hierarchy, so you can set them at the resource level or up at the resource group or subscription level. And locks only apply to the control plane, or how you would, let's say, modify a resource using PowerShell or the portal. It does not apply to the data plane. So if you lock a storage account, it doesn't say anything about who can modify the files in the storage account. So let's look at how to create locks. So in the portal, I'm at my storage account. The left blades, if you scroll down far enough, you'll find locks listed. I can add a lock. Maybe this is a production resource. We want to keep this resource and we want to prevent it from being deleted. So now I have a delete lock set on my storage account. At this point, even as an admin who created the storage account, if I try to delete the resource, it can't be deleted because it has a lock on it. So you see where the lock provides a level of safety. Now, I could also go back, find a lock like this, and if I have permissions, sufficient permissions, I can delete this lock. At that point, I could then modify or delete the resource. So locks, again, provide a level of safety. Good to use probably for production resources because it prevents even accidental changes by admins in a resource, especially delete locks. Now, another concept we want to discuss that helps you manage the hierarchy in Azure is tags. So resource tags are another way to organize your resources. As I mentioned earlier, when you create a resource, you have to put it in a resource group, right? So resource group organization for resources is required. And since resource groups play into security, you can design your resource groups appropriately to make sure that you can assign permissions up at a higher level. So tags are just completely unrelated and a nice free-form way to organize resources. For example, if you apply a tag name called environment to a resource and you give it a value of production, and you do that for all your production resources, then you can quickly find all the resources that have a tag name of environment and a tag value of production. And no matter where they are, scattered around in various resource groups and different subscriptions, no matter what region they're in, you can easily find them because they have the same tag. So you can have many different tags, in fact up to 50 different tags for a resource or resource group or a subscription. The names are simply text. The values are either text or a JSON object, a small JSON object. And so it's up to you to make sure that you spell things correctly in all places so that things get organized and you can look them up quickly and easily. Unlike resource locks, which we just talked about, which are inherited down the hierarchy and so forth, tags are not inherited down the hierarchy. So just know that. And when we talk about costing for subscriptions at the end of this lesson, we will see that you can summarize things by tag name. So having things like an environment or department as tags could make it easy for you to figure out, for example, how much is the engineering department costing us in Azure? Let me show you how to set up tags in the portal. So here I am at my storage account, and near the top you'll find tags, and you just type in the name of the tag and the value for the tag. This is a production resource. Then you apply it. And it's entirely up to you to make sure that you spell the word environment the same every place that you want to use it, and the value production. And it's entirely up to you to decide what other values are appropriate for the tag name of environment. So tags, as I said, nice, loose, free-form way for you to organize resources. Managing costs is an important part of any Azure deployment, and it's done in the portal through cost management and billing. There you can see summary and detail costs for all your resources at the subscription and even the management group levels. You can see accrued costs so far since the beginning of your billing cycle and projected costs for the rest of the month of billing cycle. Let me show you what that looks like in the portal. So here's a subscription I have in Azure, and I'm looking at the subscription resource in the cost analysis section. You can see here that the dark green represents accrued costs so far this month, and then projected costs are where Azure thinks I will be based on my current level of spending. So actual costs and forecast costs listed here as well. So a nice way to get a handle on whether I think things are going to get out of hand quickly. If you scroll down a little bit, you can also see graphs by various metrics. So this is by service name, so you can see how much a particular service is costing. You can see my SQL database is costing about $8 and my Azure App Service is costing $23. You can also view cost by location or Azure region, also by resource group name. And there are many other choices besides these three as well. We talked about tags in a previous section, so you can view resource cost by tag. This can be an important way if you have dozens or hundreds of resources to manage cost. Now, to help with that, You should also know a little bit about budgets and cost alerts. So let's look at budgets. I don't have any budgets, I'm going to add one. So a budget is a way that you can have Azure track a little bit of your spending and then potentially notify you if you're getting above your budget. So I'm going to create a budget here. I'll just call it budget 1. You need to set a reset period. I'll leave the default of billing month. And then a start date and an end date. So for creation date, I'll pick November. That's the end of my next billing cycle. And then for expiration date, expires, this is 2 years from now, but I could pick 1 year from now. You give a budget threshold. The suggested is $60, and that's just based on what my spend has been. So here's my actual spend in the previous several months. Here's my estimated forecast spend so far in this month. So what I could do is I could take the suggestion, or I could pick another number. So far I'm not above plan. If I like this budget, I go next. I can set alerts. So an alert condition is, do you want to be alerted when you hit a percentage of a budget actually or the forecast? I'm going to choose actual, and then I'll say maybe 75%. So since 60 was my forecast, 75% of that is 45. I can leave action group empty here because I'm going to list an email address down below, and I'll just put in my email address. And so this person will be emailed an alert when the cost of this subscription reaches this amount during the billing month. Set language or not, there's just a summary, and I can create. Once I have the budget created, then I can be notified when I hit my budget. So the creation of a budget also created what's called a cost alert, because that email gets sent out when I hit my budget. And so I don't have any alerts yet to show you, but I can show you a screenshot back in presentation. Here is a budget that was set up, and then cost alerts that come in show up on the cost alerts blade in the Azure portal. And so an admin who gets the alert, whether it's notified by email or some other mechanism, can come and look at the alerts and perhaps take an action. So exam-wise, you should understand just a little bit about billing, especially around the creating of budgets and cost alerts. We'll talk about a different kind of alert later, but a cost alert is specifically related to budgeting and billing for subscriptions. Azure Policy helps you enforce organizational standards. So you may have some rules as a corporation or an organization that you want to enforce for resources that are created in Azure. And so Azure Policy it falls under this category of governance, just helping you manage your Azure subscriptions, particularly as your environment matures. It's entirely optional whether you want to set this up, but it can help you assess compliance to a set of rules and even enforce those rules, sometimes even fix resources that don't match the rules. A policy itself in Azure Policy is simply a single business rule, and it's evaluated for a resource. You can see the JSON syntax shown here on the right. There's an if-then process in the policy. In this particular case, the if says, if the type of the resource is a database, then deploy if not exists. So what that really means is you could use Azure Policy to create a SQL Server database in a particular resource group, let's say. The then section of the policy rule has several different effects. So deploy if not exists is one. Other ones that are commonly used would be audit. So you can audit whether the policy rule is true or not. You can audit if something doesn't exist and report that. You can deny a deployment. So if you're trying to deploy a resource and the deny rule or effect is hit, then it prevents the resource from being deployed. In some cases, you can even modify the resource. So there are many, many built-in policies in Azure Policy Service. I'll show you those in a minute. Policies are collected into what's called an initiative. So initiative is just a set of policies. There are many built-in initiatives too, and I'll show you some of those. And some of these are for industry standards. To implement policy in your environment, you want to assign it as a policy or assign an initiative to either a resource group or a subscription. After you do that, Azure will evaluate your environment and determine whether you're compliant or not. And it gives a compliance score in Azure Policy, lets you to determine then whether you want to make any changes or not. Let me show you how this works in the portal. So I'm going to go to Azure Policy. If you don't find it on your menu, you can search for it at the top. And you can see I already have a score. This is from a built-in service in Azure called the Security Center. I'm going to skip down to definitions. And here's a set of all the initiatives and definitions that are built in for Azure. I'm going to filter this list by location. So location in the context here means region. And so there are policies defined for specific things such as what are the allowed locations, or maybe audit resource location when it matches a resource group location. So maybe you'd like to find all the resources that are in a region that doesn't match the region of the resource group. I'll look at this policy and show you what the rule is. So just understanding the basics of reading these policy rules would be helpful for your exam, and they're fairly straightforward. So the policy rule says if the location, that would be the location of this resource, does not equal the location of the resource group, and it's not a global resource, because some resources in Azure are global, then audit. And so the audit is the effect of this. And at the end, you would just have a list of resources who were in a different region from the resource group they belong to. Let's go back and look at another example. So allowed locations. This policy rule says if the location does not match one of the allowed locations that we'll specify, and it's not global, and it's not a special resource called a B2C directory, then the effect is deny. So this could actually prevent a resource from being deployed. If you like this policy, you can assign it. So when you assign a policy, you pick a scope first. A scope should be at management group level, perhaps at a subscription level, perhaps at a resource group level. I'll put it in E*G. And next, the name, you can choose the name, or I'll leave the default name, that's fine. And do I want this policy to be enabled? Yes, I do. I'm going to go next. And what are my allowed locations? So these are all the locations or regions in Azure. And maybe what I want to do is make sure that we only create resources in East US. So I've identified 2 locations that are allowed. Sometimes there's remediation that can happen. In this case, for an allowed location, we don't need to have one. We can actually review and create. And so creating this policy assignment, what that really means is the allowed locations is now in effect for my subscription and resource group. And if I try to create a resource that's in a different region than what's allowed, it will fail. So you get a sense of how policy can help you enforce some standards for your environment. Let's look back at definitions and notice that there are also initiatives that are built in. The initiatives here have a lot to offer because Microsoft has done a lot of work to find the official set of rules that are required for something like PCI. So that's the payment card industry. If you're in the financial industry and you accept credit card information, there are certain rules you need to follow when you're storing that data. And so this initiative has been established. It's really just a set of rules. And if you need to follow these rules, you can assign this initiative, just like I assigned the policy earlier. And then Azure can evaluate whether your resources are in compliance with PCI. So after you set up policy by assigning definitions of policies and initiatives, then the compliance blade is where you'll come mostly to see whether you're compliant or not. You see that my allowed locations has been evaluated and it's compliant because I have one resource and it's in East US. Okay, we're at the end of our lesson, so let's wrap up some of the important topics. We talked about the resource hierarchy, starting with resource at the bottom. Resources are collected into a resource group. Resource groups are collected into a subscription. And you can have subscriptions in a management group. So this hierarchy can also help you manage permissions for resources. That's through a process called Role-Based Access Control, or RBAC. So RBAC allows you to assign permissions not only at the resource level, but higher up at the resource group or subscription level. We also discussed the mechanism for creating custom roles so that you can fine-tune permissions from the ones that are built in from Azure. We introduced the concept of locks and tags. So locks are a way to protect a resource from modification or deletion, but they're not strictly a way to secure a resource. Tags are just another way to organize resources separate from resource groups. And so they're just text strings and values that you can use to help with that. We discussed a little bit about subscriptions, particularly around the creation of budgets and cost alerts. And finally, we discussed Azure Policy. It's a way to help enforce organizational rules and standards in your environment. So a policy is a business rule, an initiative is a set of policies. Let's discuss some command line options for these topics. So I'm in the PowerShell section, scroll down to resources. That's a good category for the things we talked about in this lesson. You can see here there's a command called new AZ resource group that creates, of course, a resource group. It has a name and a location which would indicate the region. I'll go back and let's look at new AZ resource lock. So you can tell what that does. Sets up a resource lock. New AZ tag for creating a tag. Give it a name, give it a value. For creating role definitions, there's a new AZ role definition. So that sets up a new RBAC role. And then you take that role and you can assign it. So new AZ role assignment is how you create a role assignment for a user in a particular role. So all of these topics we talked about in this lesson are listed in the resources section for the Azure PowerShell, so that makes it nice and convenient. Let's look at some AZ commands. So the AZ commands These are scattered about more. One of the ways that I look for these is just to do a web search. So this list of A to Z, you can see there's hundreds of commands listed on this page. What I'll do is just do a Control F in the browser and do, for resource group, here's one thing you do need to remember. In the CLI, a resource group is not called resource group, it's called a group. So AZ group is the command you use to create resource groups. So here's AZ group create and delete and so forth. So careful about that one. For locks, AZ lock. So there's how you can create a lock using the CLI. How about a tag? There's an AZ tag. How about role assignments? So AZ role looks interesting. If we go into that, here's AZ role assignment create. And then here's AZ role assignment. So again, I would just review for the topics that I cover in the lessons, just see if you can find an appropriate AZ command and a PowerShell command that represents those. And I think you'll be fine for these questions on the exam that might deal with PowerShell or the CLI. Welcome to Lesson 3, Manage Storage Accounts. In this lesson, we cover how to create and configure Azure Storage using two important services, Blob storage for web apps and file storage for cloud-based file servers. We also discuss techniques to secure access to storage and how to populate storage in an online or offline fashion. Azure Storage is a general-purpose file storage service. It supports 4 kinds of data. The first kind is blobs. So blobs are just files that contain any kind of content you want, and they're accessed over HTTPS. This makes blob storage good to integrate with web applications. In fact, many times people will set up web apps in Azure on a VM or as a platform service, and then store their blobs in Azure Storage so that if you're streaming video from your website, for example, the storage service can use CPU cycles streaming that data to your customers. So that can be a nice way to offload requests and work from your web app. Another use for Azure Storage is for files. So these are also general purpose files that could really contain most anything you like, but one of the big differences here is that file service in Azure is accessed over server message block. That's the protocol that Windows uses for network file access. And so as we'll see, you can use Azure File Storage as a way to have a file server in the cloud. The third kind of data you can put in Azure Storage is called tables. This is a NoSQL database. So a NoSQL database is different than a relational database like SQL Server. It stores data in tables with rows and columns, but the columns can be different for each row. So the NoSQL database in Azure Storage has largely been replaced by Cosmos DB, and Microsoft recommends that you just use Cosmos DB if you need a NoSQL store. However, table storage is still supported. The last kind of thing you can store in Azure Storage is queue data. So queue data is reliable message passing for applications. It's a place where one application can drop a message off, just a file that contains some data, and then another application could come along later and pick it up. So developers are typically ones who would interact with queues. The same is really true for tables as well. So the blobs and file services are the ones we're going to focus on, and those are the ones that usually are user-facing. We'll set up a storage account in a moment. I want to talk about some of the decisions you'll make up front. First of all, there's a performance level. There are 2 performance levels, standard and premium. Standard is a hard disk drive or magnetic drive. Premium is a solid state drive. So standard costs less, premium costs more. Depends on how fast you need the data, what kind of performance you need out of the data. You pick what's called a kind of account as well. So the recommendation these days is to use what's called Storage V2. It's general purpose storage. It supports all the 4 services I mentioned previously. It's sort of the latest culmination of all the features in Azure Storage. Blob storage is still available, but it's an older kind of account. It only stores blobs. You also make a choice about replication when you set up a storage account. This is an important choice. There are 6 different choices you can make for replication. Let's talk about them. The first is locally redundant storage, LRS. This is the least expensive. It means that there are 3 copies of your file in the Azure Data Center where your storage account is created. So 3 copies means every time your file is written, it's written to 3 different disks. This is helpful in case a disk goes bad or a sector on a disk goes bad, because there's still 2 other copies of your file, and Azure can determine what the original data was, and therefore you're much less likely to lose your data. So LRS, we would say, protects you from disk failure. One up from that in cost and functionality is what's called zone redundant storage. You still have 3 copies of the file, of each file that you create, but they're created in 2 different data centers in the same region. So this protects you from a data center outage. It costs more than locally redundant storage. GRS, or geo-redundant storage, means you have 3 local copies in the Azure region where you created your storage account, plus 3 additional copies in a secondary region. You don't get to pick that region, because Azure picks that region, has a high-speed data line between those 2 regions, and it asynchronously copies those additional files to the secondary region. So GRS protects you from a whole regional outage, as if East US went offline or something. The last 3 are kind of combinations of some of the other 2. So GZRS is zone redundant plus geo redundant. So there's 3 local copies, 1 in a different data center in the same region, and then 3 remote copies in a secondary region. RAGRS makes the geo redundant data, the secondary copies, available for read access. So normally for GRS, you don't see the secondary copies. They're only brought online if the primary Azure Data Center goes offline. So with RAGRS, the secondary copies are made available for read access. So you could hook, let's say, a report tool to that only needs read access to the data anyway. RAGZRS is a combination of everything, right? So it's zone redundant storage. It's geo-zone, so there's 3 local copies in 2 data centers, there's 3 remote copies, and the secondary copies are also read access. So each of these goes up in price. It is possible to change some to the others after you create a storage account, but it's something you probably want to think through. How available does my data need to be? So the standard performance tier, that's the HDD, supports all the replication options that we've just outlined. The premium storage does not support all. It really mostly supports locally redundant storage. And so for premium access, you're looking for performance and quick access to the data, so they sacrifice some of the replication capabilities. Let's talk about setting up a storage account in the Azure portal. So I'm going to go to the marketplace. Storage is currently on the front page. I'll click here. I'll talk about a few of these choices as I make them. Others we'll leave as defaults and talk about later. I'm going to create a new resource group. Your storage account name has to be unique everywhere. So no one else in the world can use this because it's the first part of a DNS URL. I'm going to pick a region that kind of matches my resource group. And here's where you choose performance, standard or premium. Notice with standard, I get these 4 choices. With premium, you can choose the kinds of blobs you're going to store. Typically that would be block blobs. But notice the choices here, locally redundant and zone redundant. There's no geo capabilities for premium storage. Just a quick note about block versus page blobs. Block blobs are what you would use for most applications. Page blobs are used pretty much exclusively by VMs for VHD files. It's for reading and writing individual pages and files. File shares and blobs we'll talk more about later in this lesson. I'm going to go back to standard and I will choose geo-redundant. The other 2 choices we saw, the read access for geo-redundant and zone geo-redundant, are configured by this checkbox. So if this is on, this will be a read access GRS. If I turn this off, it's a regular GRS. So I'm going to leave that off. Under advanced, just a quick tour of a couple of the other things you might see. So whether to require HTTPS for access, which you probably would want to leave on. Do you want to allow anonymous read access for blobs? You can enable that or disable that if you like. And we'll talk about storage account keys later, so I'm not going to change that either. Under networking, by default, your storage account is visible on the internet. So public endpoint, all networks. If you wanted to restrict it, you could do that. That'll be discussed later in this lesson as well. Under data protection, notice what's turned on by default. There's soft delete for blobs, which allows you to recover blobs that have been deleted. Containers, also soft delete, and so containers are what you put blobs in. Soft delete for file shares, both of which we'll discuss later. We'll also turn these options on later for certain circumstances. So I'm not going to make any changes to this page, but just wanted to show you some of the choices. Now it's time to review and create. And I'll have a new storage account. Let's talk about blob storage. So blob storage is blobs, any file, any kind of data you want to store, accessed over HTTP or HTTPS. They're organized into what are called containers. So a container is just a collection of blobs. There's only one level of containers and no hierarchy, and we'll see how that differs when we talk about file storage. When you access blobs and their containers, you can either set up access for private access, in which case an access key or a thing called a shared access signature is needed, or you can set up public access. Public access allows read-only access without logging in, so anonymous read access to blobs. Developers often place blob URLs in a web page and turn on anonymous access in many cases because then the web browser just takes the URL for the blob and accesses it from your Azure Storage account rather than back at your web server. So it's a nice way to sort of share the work in the cloud. When you set up blobs, each blob has a tier. So the tier is how accessible the blob is. Hot tier is the default. These are for files that are frequently accessed. They're always available. Cool tier files are always available, but if you mark them as cool and then you don't access them for 30 days or more, then it costs less money to store them in Azure Storage. There is a higher cost to access the blob, but overall you'll save money if you haven't accessed it in 30 days or more. So cool tier is appropriate for files that you want to leave online and you need access to potentially at any time, but you typically don't need access more than once a month. The least expensive tier is called archive tier. So those are blobs that are not accessed for 180 days or more. This is the lowest cost to store blobs, but the highest cost to access. Overall, though, archive tier would cost you less money, and it's good for files that you must archive, but you need to keep, but you maybe need to access them very rarely, once a year or less. Note that for archive tier, the file is not available immediately when you access it. The file name you will see, but you'll have to change the tier from archive to hot in order to access it. And the data retrieval can take several hours because sometimes there has to be physical hardware mounted in the Azure data center to access that data. You can set the default access tier. When you set up a storage account, the default is hot. That's probably the most common. It's appropriate, however, to sort of structure your files and use the tiering appropriately to save you money. No matter what the default access tier is for your storage account, you can change the access tier for any individual file in your storage. So you can set those tiers appropriately. Let me set up an Azure Storage Blob container, and we'll talk a little bit about access. So here I have a container I created called Web Files. It has 2 files in it, just a couple of images. I uploaded those files from the portal. You can do it this way. You can also upload the files different ways. This is probably the least efficient way to do it, but it can be quick and easy. Notice the access level for this container is set to anonymous read for the container. So that means anybody with the URL for this file can see it. You can find a URL if you look at properties. This is the URL for that file. That's a publicly available. So this is my storage account.blob.core.windows.net. There's the name of my container. There's the file name for the blob. And there's the image. I can also change the tier on a given file. Hot is the default. I could change that to cool. And now if I access that file in sooner than 30 days again, then I'll be charged a little more for accessing it. Okay, so in Azure Blob Storage, you can set up as many containers as you need. You can put blobs as you need to in those containers, and then give those URLs to developers, make them accessible, let's say, to a web application. Let's talk about a couple of features of Azure Storage that you are responsible for on your exam. So object replication is the first. Note that geo-replication is not the same thing as object replication. So geo-replication means that Azure is managing replicating that data to a secondary region depending on your replication tier or replication type. You don't control any of that. It happens automatically in the background. Object replication, on the other hand, is a feature that you can turn on for blob containers, so you can manage the replication of blobs to a secondary storage account. You get to pick which storage account. This can be used just to increase data availability, so making blobs available in different regions, maybe for safety's sake, although geo-replication handles most of that. Perhaps more importantly might be to reduce access latency. Let's say you have a geo-distributed application and it needs access to storage. Well, you could replicate the blobs needed for the European deployment of your app to a European storage account and make the access quicker. You get to create rules which govern which blobs are replicated, and you set up the rules based on a source account and container and a destination account and container. And notice this picture indicates that you could also replicate a second container to yet a different storage account. In order to turn this on, you have to turn on two settings in your storage account. One is called Blob versioning on source and destination accounts. This is so Azure can track versions of the blobs. And then another feature you must turn on is what's called a change feed on the source storage account. Change feed is like a transaction log for blobs that tracks changes that happen to them. Let me turn those on, and then I'll show you how to set up replication. To change those settings, you go to Data Protection Blade. This is where you list recovery options. Under tracking, you can see that Enable Versioning for blobs is turned on, and Enable Blob Change Feed is turned on. So I turned those on already. Now to set up replication, you go and establish your replication rules. So you first pick your destination storage account. I'm in storage 2, store 2, so I'm going to pick store 1 as my destination. And then I pick a container, the source container, web files. I have a container in my destination account also called web files. I can add filters here if I like. Copy all the JPEG files. I can also determine what gets copied, whether it's only new objects or everything, or some custom choice, objects by date, etc. Save and apply that. And now Azure will replicate that data to the secondary storage account. As those blobs change, Azure will replicate those changes as well. Okay, another feature that you should know about for your exam is called Blob Lifecycle Management. This goes back to the tiers we talked about. So you can use policies, you can establish policies in the Lifecycle Management section that help you determine rules for when to change the tier for a file. So typically you would change a blob to a cooler tier. If it's hot tier and it hasn't been modified in a while, then you could change it to a cool tier. If it's cool tier and has been modified a while, or if it's hot tier and has been modified in a long while, you could change it to an archive tier. You can also choose to delete really old files that haven't been modified or changed. So you get to decide what those rules look like. It's called Blob Lifecycle Management. Let me show you how to set that up. I'll go to Lifecycle Management in the storage account blades and add a rule. So my rule, you can apply the rule to all blobs in your storage account, or you can limit it with filters. And then for types, most blobs are block blobs. Append blobs are used for logs and things where things are just appended to the end of files. And you can choose what kind of blob, base blobs, snapshots, or versions. We'll stick with base blobs. And here's your rule set. So if the base blob was last modified more than, let's say, 30 days ago, then move it to cool storage. And then you could add another condition. If the base blobs are last modified more than 90 days ago, move to archive storage. You could also add another one you could delete. I don't happen to want to delete files, but it's important to note that these rules need to go in a down tiering order. So if you have multiple rules, the first one would take you from hot to cool. The next rule could take you from hot to archive or delete. And then the last rule could take you from, let's say, hot to all the way to delete. But you need to establish those rules in an order so that Azure can manage those files, move them to a cooler tier, and just save you money. Let's talk about Azure File Storage next. So file storage is accessed over a protocol called SMB instead of HTTP or HTTPS. SMB, Server Message Block, is the file server protocol that Windows has used for decades to access files across the network. So when you open up Windows Explorer, for example, on a Windows machine, and access files that are off of your machine across the network, it uses SMB. Files are organized into what are called shares. And a share contains files, can also contain directories, and directories can be nested to create a hierarchy, just like you have in a Windows file share. This sort of enables a file server in the cloud scenario. So you could map a Azure file share as a Windows network drive for a Windows client or a Linux mount point. And then the Windows client would see those files as if they were across the network, when in fact they're coming across the internet from your Azure storage account. By default, when you set up a file share, there's full control access to the share if you map a drive letter. You can restrict this, of course, and I'll talk about a way to do that, but it's important just to know that by default, you got to be careful when you map a drive letter like that. Maybe it'd be appropriate for an admin share for admins who you don't have to worry too much about permissions, but if you need to restrict permissions, you need to take extra steps. Let me set up a file share in the portal. So here's my storage account, and I have the file shares blade open. I'm just going to add a file share. I'll call it projects. Inside the project share, I can add directories. Inside a directory, I could add other directories. I can also upload files. I'll upload a couple of files. Okay, I uploaded a couple of files. If I go back up one level and look at projects, I can connect. And so the connect link here allows me to choose a drive letter, and then Azure will give me a PowerShell script I could run on a client machine to map that drive letter to the Azure storage share. Again, as I said, by default, this is full access control, so use this appropriately and carefully. If you really need NTFS style permissions, then we need to take extra steps. I'll show you how to do that now. For fine-grained access to file storage, you first need to set up synchronization with your on-prem Active Directory, because you need access to the users and groups to set up NTFS style permissions. You then need to enable file shares access to Active Directory. I'll show you how to do that in a moment. You also need to deploy some kind of domain controller near your storage account. So the recommended way to do that is through a service called Azure ADDS. You don't really have to know all the details of setting up Azure ADDS for your exam, but you should know that it is essentially a platform managed domain controller in Azure that replicates in some of the user group information that can then be leveraged by your Azure storage account for accessing those user objects for permissions. So once those steps are done, you can grant users and groups access to a share, so you determine which people need to access a particular share. Then you map that share in Windows like you would normally as an admin and change permissions. So you would use the regular NTFS permissions screen for folders or files to restrict access. So this is finally the full-featured replacement for an on-prem file server, because it means you can store the data in Azure. Azure has access to your users and groups. You can use regular NTFS permissions, and those are honored by the files that are stored in Azure. Let me show you where to set up some of that in the portal. So you go up to the shares level, and under Active Directory where it says not configured, you need to follow these steps. So step one is to enable some source for your Active Directory that has users and groups in it. And then step two, you can set share level permissions where you allow specific users or groups to have access to the share. Then you map it and use NTFS permissions. Okay, so the last service I want to talk about that's related to file storage is called the Azure File Sync service. This is another option for people who want a file server in the cloud, but they also want to maintain a local copy. So Azure File Sync service is a hybrid service. And you can see in the picture here that there's an Azure file share up in Azure in your storage account, but the data is replicated from that share to a local server. So you first set up your Azure file share, you populate it with the necessary data, it becomes the master copy of the file. You then go to on-prem servers, you install the file sync service and configure which shares to replicate down from Azure File Share. And then that particular server will replicate the data from Azure File Share to a local copy. Users, you see, access data from the local server. So users do not directly access the data in Azure in the file share, they access it from the local server, but the file share becomes the master copy. The nice thing about this too is you could replicate the same share to a different server in a different part of your company. And so then Azure File Share becomes fully the master copy, and then any changes that are made are replicated up, changes are merged in, and you have, a master copy. You can set up what's called tiering with the Azure File Sync service so that it will take less frequently used files and remove them from the local copy. So that'll save you space on the local server. And the master copy then, you could pull the file down at any time because the file name is still visible in the local server. It's just that the storage for that file is not maintained. Access permissions are automatically maintained for this because the files are replicated down to local Windows servers. So this is a separate service you set up in the marketplace in Azure. It uses Azure File Shares as a backing store, but it has more features, also requires you to have an on-prem copy. So that's a decision you would make as to whether you want to use the file sync service in that way. One way to secure access to a storage account is through user authorization. Every storage account has 2 access keys, and these access keys provide full control access to the storage account. Anyone with these keys can do anything they want in your storage account. Typically, you do not give these to users. They would be integrated into web applications. So the code that you write and you trust can use this access key to manage storage, and that's appropriate. Let me show you where to find them in the portal. Here's a storage account I have. I can scroll down to the access keys blade and see that I have 2 storage account keys here, 2 access keys. The portal also lists connection strings, and you can just hand these to developers to integrate into your code. You should rotate these keys perhaps on a regular schedule. You would need to rotate them if they were compromised in some way, and then just update the connection strings that might use those keys as well. So what do you do if you have customers that you want to give access to specific blobs or containers, but you don't want to give them an access key? The answer to that is called a shared access signature, or an SAS. So an SAS provides custom access to files in your storage service. SAS has a start and end time, so it expires, and that's useful. It can be restricted to IP addresses, so if you know exactly where the person is that's accessing your storage, you could restrict it that way if you wish. An SAS is signed with an access key. So that prevents someone from modifying the SAS after it's been given to them. They're often appended to the file URL that's in a web page. So the URL itself to the blob has the SAS appended, and the SAS then can be validated by Azure to determine whether access is allowed. They can be generated in the portal, but often, again, they're done in web application code, so developers can easily write a few lines of code to generate these and append them to a blob that ends up in an HTML page. Let me show you how to set those up in the portal. So back in my storage account on the shared access signature page, you fill out this screen and you can generate an SAS. So you first pick your allowed services. Maybe I'm just going to do this for blobs. I want to do it for blob objects or blob containers. Pick your permissions, start and end times, pick your signing key, and then just generate the SAS. So here's a URL to that storage container. I'll show you a different example in just a moment, but you can see how it is possible to generate SASs this way, but you probably wouldn't want to do this on a case-by-case basis. So let's kind of prove to ourselves that SASs work. If I go to my containers, I'll look at web files. I have a couple of files in here. Let's see what my access level is. So the access level for this container is private. That means that no one gets access to these files outside of Azure. If I go and look at a URL, copy this, paste it in a browser window, you can see I don't have access to this file. Now, on this page too, the properties page is a generate SAS. So it's basically filled it out for this file. I just need to pick a signing key and choose my permissions. Generate that. Here's my URL. I can now copy this URL. I go back here and paste the URL. Now I have access to that file. That's just the browser warning me that nobody else has downloaded this file and you're sure you want it. So SAS is a nice alternative to be able to provide access to users outside your environment in some secure way. Let's talk next about how to secure access at the network level. So your storage account by default is visible on the internet. And when you create it, it has a public DNS, which maps to a public IP address. So unless you have other restrictions on storage, then the URLs are publicly visible. You can restrict access a couple of ways. The first is through what's called a public endpoint. When you set up a public endpoint, you can restrict access to the storage account for VMs on a VNet, to specific ranges of public IP addresses, or even to certain Azure services. So maybe you have a VM running in Azure that's running your web application, and you essentially want to make the storage account visible to that VNet. So a public endpoint is a way you can do that. I'll show you how to do that in a moment. You can also restrict access via what's called a private endpoint. So the names here obviously sound similar. Private endpoints are just set up differently in Azure. It essentially projects your storage account onto a VNet, giving it a private IP address from your VNet. The data is then accessed by private IP, and it can be in a cleaner way to restrict access to a VNet. The two rules about that you should remember: the endpoint must be in the same region as the VNet, but it can be in a different region from the storage account. So let me show you how to set this up in the portal. I'll go back to my storage account, scroll down to the networking section, and you can see that right now my storage account is visible on the internet. If I wanted to restrict access, I could say I want to restrict access to selected networks, and I could pick a VNet. Here's a VNet I happen to have in the same region as my storage account. Pick a subnet. VNets and subnets we will discuss in another lesson, and you can enable this access. In addition to being able to do that, you can also restrict access by IP or by specific resource type. So Azure services, certain Azure services allow you to allow access in. So this essentially is the public endpoint version that I was discussing. I'll just discard these changes. And I want to switch to another storage account to show you private endpoints. So I have another storage account, store 2. It's in West US 2. I'm going to go to the networking blade here, private endpoint connections, and I can add a private endpoint. So I need to fill out these screens. So which subscription and resource group for the private endpoint resource. That's what I'm creating here. So I'm going to call this my store to endpoint. It should be in the same region as a VNet that I have. So I need to create it in East US where I have a VNet. So my storage account is in West US 2. My VNet is in East US. Now, you pick a resource. I've already chosen my storage account. I also need to choose which service. So I want the Blob service. Go to configuration, and it's detected my VNet in East US. And so when this endpoint is created, it'll give a private IP address to this storage account on that VNet. So any virtual machine that has access to that VNet or that's running on that VNet would have private IP access to that storage. This is a great way to privatize essentially a storage account. There's also an option here to create a DNS record. We'll talk about DNS in another lesson as well. So you can get to the end, review and create. And now you've restricted access for this storage account to a particular VNet in Azure. The last thing I want to talk about is how to restrict access via RBAC in storage. So we talked about role-based access control. That's a way that you assign roles to users and then they inherit some built-in permissions for how to manage the particular resource, for example, storage. So mostly with RBAC, those are administrative functions. And the exception that you can make for storage is they've added some specific roles that allow you to access data in storage. So you can use these if you like and assign users in Azure Active Directory. So these would typically be employees, perhaps ones you've integrated or synchronized from your on-prem Active Directory. And then allow those users, those particular employees, specific access to your storage services. I will show you how to do this in the portal. Go to my first storage account. Just like most resources in Azure, there's an access control blade, and I can add a role assignment. And then just note that there are some role assignments that include the word data. I'll scroll down and show you. So anything that says storage blob, data contributor, owner and reader, file, data, SMB, contributor, owner and reader, and then same for queue and for tables. So if you want someone to be able to read blobs, you can choose that role and assign that person. This is a nice way for employees to be able to grant them access to storage if they need it. If they're not using an application, maybe they're mapping a drive letter, and you want them to have file share access. So this is a great way to be able to do that if you need to. Populating Azure storage can be done in an offline or an online manner. Let's talk about the online options first. There's a tool called Azure Storage Explorer. It's a desktop application you can install from the internet. It runs on Windows, Mac OS, and Linux. You can connect to multiple storage accounts, any ones that your user has access to, anyone you have permissions for. With it, you can drag and drop. You can create and delete and view files. You can edit files in some cases. It's a very full-featured tool. It's very easy to find in the portal. If you go to your storage account, on the overview blade, there's an Open in Explorer. If you don't have it, you can download from the link. If you do have it, you can open it, it'll authorize and give you access. I use this a lot when I'm working with client storage accounts. So another online option over the internet for moving data into Azure Storage is called the AZ copy command. So This also runs on multi-platforms. It's Windows, Linux, Mac, and even in the Azure Cloud Shell. It has a fairly straightforward syntax, AZ copy, and then the next word is either copy to source and then destination. That's used to move blobs or files to or from Azure Storage. Note that the source and destination are flexible. So the source could be a local file, destination Azure Storage if you're going to upload. You could also swap those so that the source is in Azure Storage and destination is local, and it would download the file. But interestingly, the source and destination can both be remote. So you can use AZ copy to copy storage files from one storage account to another. The other version of AZ copy, called AZ copy sync, you give it 2 folders or containers and it will synchronize the source to the destination. This compares file names in modified time and copies if the source file is newer. So this is a great tool command line wise if you want to manage storage accounts. The offline operations for importing data to Azure involve a couple of choices. The first is called import-export job. So the import side of the import job can be used to import data to Azure blobs or Azure files. And the idea is you install a tool that's available on the internet. It's a Windows executable. You put it on a machine that also has BitLocker already installed. You buy your own SATA drives and you attach them to this machine. And there's some restrictions on what kind of SATA drives they can be, but I wouldn't worry too much about that for your exam. You then identify information about the drives, 1 or more SATA drives that are attached, maybe with encryption keys included. You identify the files and the folders that need to be copied to Azure Storage. So these 2 file names have to be called driveset.csv for your drive info and dataset.csv for your files and folders. So you've got these SATA drives attached, you've got BitLocker installed, you encrypt those drives with BitLocker, you specify these files, and then you just copy those files to the drives. That's basically step 1. You then physically ship the hard drives to an Azure data center. Azure will load them into your storage account that you specify, and it'll ship the drives back to you. So that's why this is called an offline version for data import, because you ship physical drives and Microsoft just offloads them to your Azure storage account. No internet connection needed. This can also be appropriate, of course, for very large amounts of data that you need to import that you don't want to chew up your internet connection with. The other side of the import-export job, of course, would be the export. So maybe you want to pull data from a storage account and put them on local drives. In that case, you identify in the portal first what data from Azure Storage you want to export. Then you send the empty SATA drives to a data center. They hook them up, they process the job you've set up that identifies which files, and then they ship the drives back to you. So import-export job you can find in the Azure Marketplace. It has been largely replaced by the other offline mechanism I'm about to show you, but import-export job is still specifically listed as a skill for your exam, so I wanted to make sure I covered information about it. The newer way to do this is what's called Azure Data Box. So Azure Data Box does have an online mechanism or online aspect to it, but we're going to talk about the offline aspect. So in that case, in this diagram at the bottom, you see Data Box Disk, Data Box, and Data Box Heavy. These are drives, but they're drives that Azure owns. So you essentially rent the drive for a week or 10 days, they ship it to you, you fill it and send it back. This is probably advantageous because it means you don't have to buy the hardware, the SATA drives, and send them into the Azure Data Center. And the different sizes are just depending on how much data it is you need to move. Data box disk is, about this big. A data box is like a luggable you carry with two hands. A data box heavy is on wheels with a handle. So you buy or you rent the appropriate data box that you need for the amount of data you need to move, and then Azure will move the data into your storage accounts. So in this lesson, we've talked about Azure storage accounts. We discussed blob containers that are accessed over HTTPS, often used with web applications. We talked about file shares. These are accessed over SMB and often map drive letters for users that might be using desktop clients. We talked about ways to restrict access to storage via the 2 access keys, shared access signatures that are signed by those keys, or even by RBAC roles if you want to allow access to data, specific data inside your storage accounts. We mentioned Azure File Sync as an additional service that uses Azure Storage as the backend. It's different than file shares in that you must have a copy of a Azure file share on a local server. So it provides a nice way to replicate a master copy into Azure Storage. We discussed how to restrict network access to storage, that by default, storage is visible on the internet, but you could privatize it for particular VNets or IP addresses by using public endpoints or private endpoints. We also looked at tools to use Azure Storage. So in addition to the portal, there are desktop tools like Storage Explorer. AZ Copy is a command line tool. And then there are some services or setups you can do in the Azure portal if you want to manage offline load of data. That's import-export job or data box. Finally, let's look at some command line choices for using storage accounts. So I'm in the PowerShell documentation. I have scrolled down in the reference to storage, and here's where you can see in the new section, I'll show you Azure Storage Account. So here's a new Azure Storage account for creating an account all by itself. After you do that, new AZ Storage Container would be for setting up a blob container. New AZ Storage Share for setting up a file share. Here's also things related to shared access signatures. New AZ Storage Container SAS token and Storage File SAS token. So both of those relate, well, file relates to shares. Containers relate to blob containers. Here's also AZ Storage Blob SAS token. So the words they use, fairly straightforward if you understand the terminology of Azure Storage. Let's look at the CLI commands for the same. I'm looking at the CLI reference, the A through Z list. Let me just scroll down until I find storage. So here's AZ Storage Account, which allows you to create a storage account and do various other things with it. There's also, I'll go back and show you, once a storage account is created, AZ Storage Container. So here here's commands for managing blob containers for storage. There's blob container storage create and so forth. Also AZ Storage Share, create, and so forth. For managing shared access signatures, notice Things like AZ Storage Share Generate SAS generates one of those for a share. I'll scroll back up towards the top. Here's Storage Account Generate SAS, so that's for the whole storage account. Storage Container, I showed you that before. Storage File Generate SAS, there will also be one for Storage Share. There's Share Generate SAS. So again, knowing the terminology that Azure uses and then the hierarchical nature of CLI commands, you can pretty easily recognize, I think, the mechanisms and the command that would be used to create various things. Welcome to Lesson 4, Manage Azure App Service. In this lesson, we explore Azure Platform Services for application workloads. We'll learn how to deploy a web application using App Service instead of a VM. We also discuss how to manage networking for App Service and how to configure it after deployment. Azure App Service, also called Web App in Azure, is a platform as a service offering in Azure. So instead of setting up a VM and running your web code on a VM like IIS or maybe Apache on Linux, Microsoft provides infrastructure and a platform that's already running the web service code like IIS, and you just install your code on it. So when you set up App Service, it is deployed in what is called an App Service plan. I'll show you that in just a moment in the portal. The nice thing about an App Service plan is multiple web apps can be deployed to an App Service plan. This is similar, if you want to think of a concept, as having multiple web apps installed on IIS that's running on a Windows server, let's say. The App Service plan has a tier which determines pricing, and we'll talk a good bit about that in this lesson. You don't need to know pricing, but there are different features available at different tiers. An important thing to notice about Azure App Service is that web apps cannot be moved across regions. So many resources in Azure can be moved, but web apps cannot. And so if you need a web app in a different region, you either need to copy all the code yourself, or if you use a repository scheme like Azure DevOps to move your code, you can just deploy the code in a different region and configure a new web app. So let me show you in the portal how to create a web app. I'm going to go to the Azure Marketplace, and here's a web app right here. You need to pick, of course, your subscription and a resource group. I'm going to create a new resource group for web. Your web app has to have a name and it has to be unique. So my best app, for example, has been taken. And here you can see the suffix of the DNS name. So this is going to be a public DNS, so I need to have a name that no one else has chosen. You can choose to publish the code from traditional, like .NET code or Docker container. I'm going to stick with code. I'll pick a runtime stack like .NET. Operating system, what region do you want to create your web app in? And then it's going to create an app service plan, and I'll talk about this plan later. But it's also chosen a tier for me. So standard S1, we'll talk about different tiers later. For deployment, I'm not going to do any deployment at this time. I'm not going to change anything about the monitoring. So I can review and create. So Azure will create the web app inside of a new app service plan, and when it's finished, we'll have a look. So one of the things we will look at when I go back and show you in the portal is about scaling for web apps. There's two ways you can scale. You can scale a web app up or down. That's called vertical scaling. That is a way that you change the tier. So that'll also affect your price. So you add a higher tier and you can have more features and it's going to cost more. So that essentially is like changing the size of the underlying infrastructure that's running your code. The other way that you can scale a web app is called horizontal scaling. So you scale out or scale in. Think of this like a web server farm. You know, if you had a load balancer and you had some VMs behind it that were running web apps, if you added a new VM, then you have more VMs in the back end that can handle incoming requests. The same thing exists here. So you can add or remove instances of your web app to handle throughput more efficiently. So scaling out and in happens at the app service plan level, as we'll see, and it's available at certain tiers but not all. So the manual scaling is available at the B1 tier and above, and I'll describe some of those in a moment. The auto scaling is available at a higher tier, S1 and above. So B stands for basic, S stands for standard. So when you scale out, the whole app service plan is scaled. That's one thing to note too. So if you have multiple web apps installed on an app service plan, then they will all be scaled the same way. And there is an additional charge for each instance. So whatever your charge is for one instance, if you scale out to 3 instances, then your monthly charge would be 3 times. Let's go back to the portal and we'll look at scaling. So my web app is finished. I'll go to the resource. So on the overview blade for my web app, you can see that I have a public URL here. So this web app is visible on the internet already. Obviously, I need to put my code on it. My app service plan is listed here, and I'll show you some of those features in a moment. And we'll talk in this lesson about many of the other features for web apps. So scaling, you can look at some of the scaling in the blades for app service. Here's scale up and scale out. So both of these will take us to the app service plan level. Let's talk about scale up first. So for scale up, this is about changing the size or the tier. So tiers for an app service plan come in several different levels, and different levels have different features. I'm currently at a production level tier S1. And so if you scroll down on this list, you can see the included features at S1. Some of these features we will discuss in this lesson as well. Other tier brackets, the P tiers are premium tiers and they cost more, and you can see that evidence in just the estimated monthly costs. There are also dev and test tiers. So there's a B1 tier, which is basic, a D1 tier, the D is actually from the D in shared, and there's even a free tier. So notice at the free tier, you get very little. At the basic tier, you can start adding other features. At the B1 tier, you add even more and so forth. So you can come at any time and change the tier of your web app. I'm going to leave mine at the S1 tier because it's useful for some of the features we're going to discuss. And in fact, that feature is auto scaling. And I want to discuss scaling out next. So here is scale out for my app service plan. I'll just click on this blade. I currently have 1 instance running. At manual scale, I can just change the number of instances. And if I hit save, I'll get a second instance of my application running. I don't have to set up the load balancer. It's built into what Azure App Service will provide. And so I'll just have 2 copies of my web app code running behind this. Customers will connect to the load balancer in the front, and all the requests will be shared among the available instances on the back end. So a very nice feature of the platform web service. Custom auto scale allows me to set up rules that Azure will use to scale, which is really neat. So I can scale on a metric here and add a rule such as, let's say if my average CPU percentage, and here's a list of what it's looked like, here's a graph of what it's looked like recently. Let's say if the average is greater than, pick a number, percentage, for more than so many minutes, then please increase my instance count by 1. And then 5 minutes later, check that again. So adding a rule like this means that Azure will automatically scale my web app based on load, CPU percentage load. You would typically add a second rule that scales in. So probably pick the same metric. There are many metrics you can choose from. CPU percentage was just the default and it made sense. So if my CPU percentage is less than 25 for a period of so many minutes, I want to decrease my count by 1. So adding these rules and saving them means that Azure will automatically then manage my instance count or scale out or scale in my web app as needed based on load. That's available at the S1 tier and above, and you can kind of see how that would be useful and helpful in managing throughput for your web application. One of the first things you might notice if you set up a platform web app is that Azure assigns you a DNS name. That's a public DNS name, and that's how your app is currently known on the internet. All those public DNS names end in azurewebsites.net. If you already have an existing web app, or you want to hide the fact, perhaps, that you're deploying to Azure, maybe you have a DNS name by which customers find you already, you need to add a custom domain name to your web app as well. So as long as you own the DNS domain, you can add the entry in the DNS zone. You can prove to Azure that you own it. And then essentially you have a CNAME record in the DNS zone that points over to your Azure web app. This is supported at the D1 tier and above. And so D1 is the shared tier, just above the free tier. Once you set up a custom domain, you might also want to import the certificate for that. So you need a TLS certificate to do HTTPS traffic. The Azure assigned domain name does have a certificate, but if you're going to replace that domain name, you need to bring your own certificate with you. So if it's a custom domain like that, you can either import the certificate that you own, upload one. You can buy one through a mechanism in the portal. But what you're really uploading there is a private key certificate. That's a .pfx file. And that allows the web server, as communicating with the web client browser, to exchange a key that can be used for encryption between the client and the server. That is supported at the B1 tier and above. So that's the basic tier, just below standard. Another kind of certificate you might need in your application is if the code of your application accesses another service. So it might access a service outside of Azure, or even in Azure, but maybe it's a web service that your code needs to call. In a case like that, you need to import another kind of certificate. It's called a public key certificate. It's a .cer file. Essentially, your web app is being a client to another web service or server that would have a private key certificate, but you need the client-side version of that, which is the public key. Those also are supported at the B1 tier and above. Let me show you how to do both of these in the portal. So first, we notice for my web app that this is the URL that Azure assigned me. And if I want to hide that behind something else, I need to add a custom domain. So you can add a custom domain here. I'll do acmeparts.com. I do not own that domain, but Azure gives me the instructions for how to prove that I own it. I have to go to the DNS zone for Acme parts and add in either an A record or a CNAME record. And once you do that, you can prove to Azure you validate here. Azure will validate that, and then your domain name will redirect essentially to this web app in Azure. So once that's done, you might need to import a certificate. Here's the TLS settings page. Notice a couple of other settings too. So by default, HTTPS only is turned off, which means you do allow people to find your site by HTTP without using encryption. That's your choice. TLS version is also listed here. If you're going to import a private key certificate, then you can do that on this tab. You can import. If you need to upload or import a public key certificate, you can do that here. So all these are related to the fact that you might set up a custom domain, or your web app code might need to access another service that requires certificates. Okay, once your domain names are settled, there's other things we should consider regarding web app access for networking. So the next section here, I'm going to talk about web app inbound access. And it's important to sort of keep this straight in your head as you think through how you're going to connect to your web app and how your web app might connect to other things. There is a nice portal page. Let me show that to start, and then I'll come back and talk through some of the points of this. So if you look at the networking blade for the web app, there's a nice picture here that sort of lays out inbound traffic for my web app. Here's my web app. And the outbound traffic. So use this image as a way to sort of think through this for yourself. The idea is, who's going to be allowed into my web app? You can restrict that with the inbound traffic sections, and I'll talk about these in a moment. Outbound traffic is things that your web app needs to talk to out there that are not local. So they could be other things in Azure, they could be things you have on-prem or in other places. So let's talk about various parts of this. We'll start with the inbound traffic. So you can restrict access inbound by IP address if you'd like. By default, it's visible on the intranet, but if you want to specify one or more IP addresses that can access your web app, you can do that. And so that could be used maybe if you have some code running on-prem or clients running on-prem that you want to access the app service, and you know the public IP address of your corporate firewall, then you could restrict access that way. Another way you can restrict access is by VNet. So inbound-wise, you can say that you have a workload running on an Azure VNet that needs to access your app service. So I'll show you how to do that momentarily, but you identify a VNet, and essentially Azure then can restrict access from that VNet to your app service. You can also restrict access by what's called service tag. So service tag just means other services in Azure. So perhaps you have a certain kind of service that you have running workload. It's got some code running. It wants to talk to your web app. Maybe your web app is a web service. And so you can identify services in Azure that are allowed to access your web app. Finally, you can restrict access by what's called private endpoint. So the private endpoint details I'll cover in the lesson on virtual networking, but here's the idea now. A private endpoint essentially gives your web app a private IP address on different VNets in Azure. So you could have a VM running on this Europe West VNet, and the private endpoint here means there's a private IP address that any VM running on the VNet could use to talk by private IP to your web app. So that's a powerful feature if you want to really make the web app that you have deployed into a private access only. This is only supported at the P2 and P3 tiers, so this means it's going to be an expensive option. It's not terribly expensive, just depends on what you want to pay for and what you need. As I said, it gives you a private IP address on a VNet and then disables internet access. So it's another important point. Once you set up private endpoints like this, you've essentially privatized your web app. Let's talk about how to set up some of these inbound things in the portal. So I've set up a couple of access restrictions already for inbound traffic. You do that by establishing these rules. So the rules allow you to choose a type of rule it is, and then assign a priority. And the priority of the rules determines the order in which they're evaluated. If a rule matches and the action is allow, then the access is allowed. If nothing matches, or it does match a rule that the action has been set to deny, then of course the access does not go through. So this particular rule here is an IP rule that I set up, and I chose it based on IP address. Actually, let me show it to you this way. Let me add a rule, because when you add a rule, you can see your choices. So when you first add a rule, allow or deny, choose a priority, and then your type. And so the type of rule, here's IP address restrictions, and for that you would specify an IP address or an IP address block. If you want to set up a VNet rule, you choose a VNet. Here's my East VNet, here's the subnet. So I would be essentially projecting that web app onto the VNet for access. I could also do by service tag. And so service tag has you pick one of those Azure services that might want access to your web app. So as you set up a new rule, you choose its type, must choose a priority as well, and then the rules are managed as you see here. I have currently a rule IP address wise only allowing access from this IP address. I have a service rule for logic apps. I have a VNet rule for East VNet. What that should mean is that my web app is not visible on the internet. Let's see if that's true. If I scroll up to my overview and I click on my DNS name, you can see my web app is now unavailable. So the restrictions I have put in place make this not visible on the internet. Last thing I'll point out down here about inbound rules is private endpoints. And I don't have any private endpoints set up. I'm not at the P2 or P3 tier, so I'm not allowed to create them here. Next, let's talk about outbound rules. So outbound access is what your code needs to talk to out there that, that's not local to your web app. You can set up outbound access for VNet integration. So don't confuse this with VNet inbound. That's when something on a VNet is contacting your web app. This is when something on your web app is contacting something else on a VNet somewhere else. The way you do that is you set up access to identify a particular VNet. It's supported at the S1 tier and above, so standard tier and premium tier. Essentially, your web app is projected to the VNet subnet, and then it can see by private IP things it needs to talk to. When you set it up, you must first create it on an empty subnet on that VNet, so nothing else lives on that subnet. And then if the VNet is in a different region than your app service, you have to have a point-to-site VPN set up. Let me show you that in the portal. So here's VNet integration. I can add a VNet. There's my VNet. Notice same region, I could choose East VNet. Notice here also the indication. If there were other regions, I would have to have VPN gateway set up point-to-site for the other regions. I'll just choose same region here. And then select existing. There are no empty subnets, right? So that rule of when you first set this up, you have to have an empty subnet to put it on. So I could create a new subnet here if I wanted to. Call it web apps. I need to choose IP address block from my VNet and then enter something that works. 1.0, that should work. Oh, /24. Now the other choice for outbound access is to set up what's called a hybrid connection. So this is an interesting choice if you have code running in a web app and it needs to talk to something on premises. So imagine you have a database on-prem and you left it on-prem for security reasons perhaps, but your web app out there in Azure needs to talk into that database. Now you can set up this hybrid connection even without a VPN installed. So this is a nice feature. You install what's called a hybrid connection manager. That goes on the on-prem server somewhere in your environment that's network connected to your database. The hybrid connection manager sets up a thing called an Azure relay. And what that allows is bi-directional communication from your web app over port 443 on the internet to whatever's behind the firewall to the connection manager. The connection manager then manages the connection to the database. So this is a great option if you have to split your web app workload into a hybrid solution. I'll show you the beginnings of that in the portal. When you set that up, here's hybrid connections. From here you can download the connection manager. You have to install that on a local server and then you authenticate it. You can add the hybrid connection in. It would connect to the server and talk and set up the Azure relay over port 443, and then you're ready to go. So there's quite a lot to think about with web app network access. And again, I would encourage you to use this page in the portal to help you sort of keep things straight. Think in terms of, are things connecting into my web app or is my web app connecting out to other things? That'll help you work through a question that might ask you about what kind of services you need. There's a few other features I want to talk about for a web app. First would be for authentication and authorization. You can enable what's called authentication for your web app in order to require users to log in to use it. Many times developers have done this in the code of the web app, and that's still appropriate in many cases. But it's very easy in Azure, in the portal itself, just to say, I want to use Azure AD or Facebook or Twitter or somebody else's identity database to authenticate my users. This goes back to the discussions we had in an earlier lesson that Azure AD is a trusted provider, and so it talks well with other trusted providers, and Azure Web App also trusts other providers like Facebook and Twitter. Let me show you how to do that in the portal. From my web app, I scroll down to the authentication blade and choose an identity provider. So if I pick Microsoft, that's Microsoft's Azure AD and Microsoft APIs, essentially we're saying you can only access my web app if you have a user account in my Azure AD. Same thing with all of these others. And then you can establish permissions as well. The other concept I want to talk about relating to this is identity. So identity allows your web app to establish who it's running as when it talks to other services in Azure. So let's say the web app needs to talk to a database, and the database is deployed in Azure as well. You could store some credentials in the web app that would allow access to the database, but it would be more secure if you set up an identity so the credentials weren't stored in a file in your application. Instead, Azure just naturally hooked it up because of these credentials. So when you set up identity in Azure, go to the identity blade. There's two types of identity, system assigned and user assigned. System assigned identities are tied to this specific resource. So essentially Azure creates what is more or less a user account. It's a service principal it's called. You don't log in as this user, but this user is how my app is known for other Azure services. And once that identity is established, you can go to the app service itself and then use role-based access control to allow my app, or the system assigned identity for this app, to access that service in whatever way is appropriate, read, contributor, etc. So system assigned identities are tied to the resource. And I'm making this distinction because if you delete the web app, the system assigned identity gets deleted as well because it's tied to the resource, it's tied to the lifecycle of the resource. User assigned identities are ones that can be shared across resources. In fact, here, you don't add them here, you assign them here after you've added them elsewhere. And so you find them under user identities, managed identities they're called now. And so you can create a managed identity, and then this identity can be shared or used as the identity for multiple web apps. So concept-wise, I would just keep track of the fact that a system-assigned identity is tied to the app itself, whereas a user-assigned identity can be shared across multiple apps. Another feature to be aware of is web app backup. So backup creates actually a zip file in Azure Storage that contains a backup of the code for your web application, also configuration files, and possibly some eligible databases, depending on the kind of database you're using. If it's difficult to recreate your web app, it might be useful to set up backup so that it's easier to restore. It's supported at the S1 tier and above, so standard and premium, and then you can configure how often and how many backups to keep. The other thing that's similar to that is called a snapshot. This is an automatic incremental shadow copy of your web app. So it's a little more sophisticated than a backup. That's why it's enabled at the P1 tier. These can be useful if you want to capture incremental copies of your code in case you need to restore something. I should say too that both of these might not be necessary for some kinds of applications. Many times the web app code for your application is kept in an external repository like Azure DevOps, in which case it's very easy to recreate the application anyway by redeploying the code. So it's your choice whether to set up backup, but if you do, you can find it in the web application under backups. So you configure backup by choosing a storage account and then a schedule. And for your schedule, you can back up a certain number of days or hours, no more frequently than once an hour. And then you specify how many days to retain the backups and whether to keep at least one. If you have eligible databases, they'll show up here. It's noted from the configuration file for the application whether your databases are eligible. Just note that this is different than a VM backup, which is discussed in another lesson. This uses your Azure storage account. So the cost of this backup is actually based on the data space you'll be using in your storage account. The last thing I want to discuss about this is for deployment. So you can use what are called deployment slots to deploy multiple web app instances for different environments. So this is not like scaling where all the instances in scaling are visible to your customers and accessible by your customers. Instead, these are for things like test versions of your app, staging versions, things that you might use before you move changes into production. Each slot has a different different DNS name, and so they're accessed by a different URL. And it's very easy to swap slots to exchange code between two different versions. Let me show you what that looks like. So if I go to the portal and look at deployment slots, I can add a slot. And let's say I add a staging slot. So a staging slot is going to be a different copy of my code that's accessible by this URL, mybestftrh-staging, azurewebsites.net. And then these two slots, when they're finished, can be easily swapped, as I'll show you. So I could then deploy code to the staging slot, let's say new version of my code, because I'm testing some changes. And if the testing goes well, and I want to take this code that's in staging and make it production, then I do a swap. And the swap just moves the staging code into production, moves the current production code back to staging, and essentially it just swaps the DNS name entries and the IP addresses so that it doesn't actually have to move code physically. But so it's a very quick operation. So it's a really neat way to be able to change new versions of the code for what's in production. And the nice thing about a swap is if right after the swap you discover some horrible thing happened, you could easily swap back because your old production code was moved to the staging slot, and you could quickly move it back before you changed anything else in staging. Okay, my swap finished. One more thing I would like to say about slots that's a nice feature is this traffic column. So if you have new code in staging and you want to test it on a few customers, you can specify a certain percentage of traffic that could be sent to the slot. And so 20% of the requests will go to the new code, while the rest stay with the original production code. So this can be a nice way to do some really final testing with actual users that are going to be using the app eventually. So this also is a feature that exists because your web app in Azure, Azure Web App, has a load balancer in front of it, which allows you to have these slots so that you have one place that clients connect to, and the requests are farmed out to the appropriate slots behind. Now, the last thing to discuss about this is deployment. So there's a blade called Deployment Center that allows you to manage deploying web code to your web app. Many people store web source code in repositories like GitHub or Azure DevOps, and Azure makes it very easy to pull that code in and use it as the basis for your web application. That's managed in the portal at the Deployment Center blade. So your choices here would be things like GitHub or Bitbucket. There's Azure repos from Azure DevOps. Those are some automated ways you can deploy code. There's also manual ways if you have your code in Dropbox or on OneDrive. It can be fairly simple to specify those as well. If you need old style like FTP, you can look up FTPS credentials, and Azure provides you an FTP URL that you can use to upload for your deployment. So lots of choices for how you need to get your code into the web app as well. To finish up this section, let's compare app service features. So we talked about these features throughout the lesson. What I would look for in terms of how to remember some of these is where the breakpoints are. So the tiers are across the top. You have a free tier, shared, basic, standard, premium. Isolated is a tier that means that it's the highest price tier, and it is the tier that automatically privately deploys your web app to a VNet. That's the most expensive. It also has the biggest numbers on it, as you can see. But look for breakpoints in terms of how to remember these. So custom domains start at the shared tier and go up, but TLS certificates are at the basic tier. Also notice that manual scale is supported at basic. Auto scale is not supported at the basic tier. If you want auto scaling, you've got to be at the standard tier or above. Staging slots and backups and those things are also only supported at the standard tier and above. So just take a look at this and get an idea of which tier might be appropriate for the kind of question that might ask if you need this feature, if you need that feature. I think that that will help you answer those questions. So this lesson has been all about Azure App Service. Azure Apps Service, also called Azure Web App, lives in an app service plan. So the plan is like a container for one or more web apps. You can scale out and scale in. That's called horizontal scaling. You can set up manual or automatic scaling rules. You can scale up and down. So that's adding or changing tiers so that you pay more for more features. You also might set up custom domains and then import certificates that go with those custom domains. We talked about network access. On the inbound side, you can restrict access to your web app by IP address, by VNets you have established in Azure, or by service tags for Azure types of services. You can set up outbound network access also to VNets or to an on-prem resource using hybrid connections. We mentioned a couple of other features of web app, such as authorization for restricting login access to your app, identity for managing how your app is known to other Azure services. We also looked at backup and snapshot as ways to protect the code that you have for your application. And finally, we talked about deployment slots as a way to have extra versions of your app used for testing purposes. Let's look at a couple of command line items and we'll finish up the lesson. So for PowerShell, you find these commands under App Service. And here you see new AZ Web App. So that's how PowerShell signifies the setting up a web app. For the app service, there's a new AZ App Service plan. All right, so they call it an app service plan like we might expect them to. Also a couple of other things like here's new AZ Web App slot. AZ Web App Backup, if you want to set up backups. For the CLI, everything you'll find about web apps is under AZ Web App. So you can look for AZ Web App Create. Probably expect that to be something that you would use to create a web app. You can also look for, there's a scale operation. If you wanted to look for slots here, I'll just search for slot. Notice slot is listed under AZ Web App deployment slot. So they add that extra deployment word in there. So be careful about that. So this would be a way to create AZ Web App deployment slot create, and there's the swap thing for web app deployment slots. So I would encourage you to just scan a few of these to just be familiar with some of the, particularly the nouns that they might use, the descriptor words they might use for getting to the various sections of the AZ commands. Welcome to Lesson 5, Manage Docker Containers, where we learn about Azure support for Docker-based applications. We cover two important services: Azure Container Instance, a platform environment for running a Docker container, and Azure Kubernetes Service, a full-featured container orchestrator that manages scaling, health, and maintenance of Docker applications. Let's begin our discussion of containers by describing what a Docker container is. So the idea of a container is a concept invented by a company called Docker. A container is simply an application that has special features, some of which we'll talk about. The Docker engine is the runtime environment that you have to have installed on a machine in order to run a Docker container. So here you can see the Docker engine running on top of a host operating system, and the apps that are running, if they're containerized apps, if they're written to talk to the Docker engine, then these apps are called containers. So containers have some special features. The first is that they're binary compatible. That means the code for a container is compiled and stored. It can be loaded and run without being recompiled. This is true even if you change the operating system. So the host operating system can be different, and you can run the same compiled code as a container on a different host. Containers also allow for isolation of applications. So app A that's running on this Docker engine doesn't know about, is not aware of the other apps that are running, and the changes it makes, even to the file system and the registry, are isolated from other applications. Containers are highly scalable because they're kind of like a process running. And for that reason, they're also very fast to start up. So you can get a container app up and running in a matter of milliseconds because it's just like launching an application. One of the places you'll see containers in Azure is with Azure Web App. So as you deploy a web app in Azure, you can use, instead of source code, like .NET code that would be compiled and run in the Azure Web App, you could deploy a Docker container. It's very easy during the setup of a web app. You just make a choice that you want to use the Docker container. You pick the Docker container image that you want to use, and Azure will just load and run your container image. So image sources for containers can come from different places. You see here some choices available. Docker Hub is one. Docker Hub is kind of like GitHub, which stores source code. Docker Hub stores compiled containers that applications can use. So any public source code that is shared can be loaded from Docker Hub. Azure Container Registry is another choice. We'll talk about that very soon. It's a place where you can store your container images. You can also choose a private registry, which is just a third-party location where your Docker container images are stored. Let me show you how to set this up in the marketplace. So when I set up a web app, I can choose my resource group as normal, a web app name, and instead of code, I'll choose Docker container. Choose the underlying OS you want to run this container on. Linux is common, but it's not required. A region, you need an app service plan as usual. You go to the Docker tab, and now your choices here, where is your image source? Here are the three choices I discussed in the slide. Here's Quick Start, which is just a sample website you can load. I'll keep the rest of the defaults. And we can review and create. You'll find when you're finished that this web app looks and operates like a .NET web app that you might deploy using standard platform instead of a container platform. My web app is finished. Let's go have a look. So This looks like the Azure portal pages for a regular web app. If I click on the URL here, this is a standard web app, but it's running a Docker container image. Another service you might set up in Azure if you do container development is called an Azure Container Registry. So the ACR is simply a library or repository of Docker container images. You set up the library. It's just a storage location in the cloud in Azure. It has a URL, as you can see here. And companies like this, if they don't have open source code, because even their compiled images should not be shared with other people. So ACR is a nice choice if you want to privatize your containers. There are 3 tiers. The basic and standard tiers mostly differ in the maximum size of the registry and how many images you can throughput in a given bandwidth of time. The premium tier adds geo-replication features and also private endpoints. Let me show you how to set up an Azure Container Registry in the marketplace. It's very straightforward. Here I am in the marketplace. I just need to fill out the typical things for resource group, a registry name that is unique, a region, and the SKU. The networking and encryption choices cannot be changed at the standard tier, so I'll just create the registry. So my ACR is created. Let's go have a look. You'll find with the Azure Container Registry that there aren't too many settings you make or changes you make in the portal. You can look at access keys. Here's one item you might want to know about for your exam. In order to use the typical command line Docker tools to upload items to this registry, you need to have a login account. And so you can enable the admin user here. And then if you look at the pop-up here, it tells you the rest of your clue, which is you use the registry name as the username and then the admin user access key. So you use one of the access keys as a password to be able to upload to your private registry. The other blade in here that you can look at is repositories. The repositories blade is empty here because I haven't uploaded any images yet. So you cannot upload images from here. You would use the Docker command line tool to do that, but then you would see them here. To finish up this section, let's talk about some Docker commands that are commonly used. So developers typically run these commands, but you should have just a passing knowledge of how the Docker commands might be used. So Docker as a command line tool was written by Docker the company. It needs to be installed on a machine, typically a Windows client or a VM or a Linux client. And then the Docker engine is running on the machine, and then you can run Docker commands. So some common commands. Docker build is what a developer would do to take source code and turn it into a container image. Docker run is a command that's used to load a Docker container in as a running app on the local machine. So the options here which might be of interest, -D means detached, which means after this command runs, it comes back with a command prompt. So it runs the app and leaves the app running. -P specifies port information. So that's the internal port and a colon and then the external port. So it looks like this app is probably listening on port 80. One item you need to know about for Docker in using the Azure Container Registry is Docker tag. So you must tag an image before you can upload it to your ACR. Here's an example of that, Docker tag, and then the name of the application you want to tag, and then you tag it with the URL for your Azure Container Registry, and typically the app name. And then when you do a Docker push, push is used to upload to a registry, but if you tag with your ACR name, then the push will push to your registry. So this is how you upload an image, and get it in your registry. Just a couple of other commands to cover. Docker images is how you can look at the images that are loaded on the current machine. Docker PS shows running containers. So if you did a Docker run up here, detached my app, then Docker PS would show that my app was running. There's a Docker stop and Docker start command used for just that, stopping and starting applications. And then the Docker RM commands. The RM my app removes the container. RMI, Docker RMI removes the image from the local machine. An Azure Container Instance is another service Azure provides that helps you work with containers. It's a quick and easy way to run a Docker container in Azure without having to set up a VM with the Docker engine. An ACI is a platform as a service environment that Azure provides. It essentially is a VM underneath that's running the Docker engine, but you don't have to set up the VM to run it. You just specify during setup which container you want to use, and Azure will load that container, and then you have an up and running container instance. You can specify a few things during setup. Public IP address is typical and by default. You can set up a DNS name if you want to find your container from the internet and DNS. You can also specify port information. The Azure Kubernetes service, which we'll talk about later in this lesson, can also use the ACI for overflow demand. So if it quickly needs access to a container instance, AKS can spin up an ACI, an Azure Container Instance, sort of borrow a PaaS environment to run your container while it's setting up some more infrastructure within AKS. We'll cover more details of that later. Let me show you in the portal how you can set up an Azure Container Instance. So here I am in the marketplace, and here's a container instance. I'm going to fill out a few things. I need a name for my container that's unique in my subscription. Pick a region. And then again, choose an image source. So quick start image, Azure Container Registry if you have that set up, or from Docker Hub or some other private registry. I'll use the quick start image. Specifying a size for this PaaS environment. Under networking, you get a public IP address by default. If you want to specify a DNS name here, you can. And you get port 80 by default. You could specify other ports if you'd like. Restart policy also. You can specify here what to happen if your app crashes for some reason. Do you want Azure to restart it if it fails, to always restart it, to never restart it? These choices may not apply for, say, a web application listening on port 80 because you would expect it to be running anyway. I suppose always might work in that case. The other choices you could use if your container might exit, as in if it completes its task and it exits, should it restart automatically? Or should it just not restart and only run once? Once you're finished, you can review and create. And I'll show you the choices after the deployment is finished. So my container instance is finished. Let's look at some of the settings. As we saw with Azure Container Registry, Azure Container Instances also doesn't have a lot you can change in the portal. There's an overview blade that summarizes the Azure Container Instance. You can look at the Containers blade, and it'll show you that I have one container and it's running, how long it's been up, and if it's had to restart. There's some stuff at the bottom of the screen you might see here too, some recent events that relate to that container. You can look at some properties. The Connect tab allows you to open a command prompt if you wanted to be able to, say, issue Docker commands to that container from within the portal. Just remember, Azure Container Instances are a way to run a container in a PaaS environment. Azure Container Registry, even though it sounds similar, the registry part just means it's a library. It's a place where you can store your images. Both of these services can be used together or independently in Azure. The last topic in this lesson is about the Azure Kubernetes service. Before we get into that, let's talk about what Kubernetes is. Kubernetes is a platform developed by Google. It's a container orchestrator, so it helps you manage large numbers of containers. Container lifecycle, the starting and stopping of containers, scaling out a container group so that you can handle more throughput. The orchestrator also helps you manage networking, storage, even upgrades to applications, which can be rolled out piece by piece. Kubernetes developed this for its own use, but then published it as an open specification. And so Azure Kubernetes Service, or AKS, is Microsoft's implementation of Kubernetes. You do not have to be an expert in Kubernetes for your exam because you're an Azure admin, but you should know some terminology and work with AKS just a little bit so you're familiar with some of the concepts. Some of the terms you'd see is the word pod. So pod is the Kubernetes term for a running instance of your container. So whereas Docker talks about containers, Kubernetes talks about pods. Pods are deployed to a node. Well, a node is a VM. So that's a nice place you can hang that concept in your head. So you can have multiple pods deployed to a node. And the nodes are grouped into a node pool, much like you would, if you create a load balancer, you'd have a back-end pool that contained a set of VMs. So using those terms, let's look at a picture that describes some of this. You can see AKS shown here on the left. It has a set of nodes. So remember, a node is a VM. Each VM has a set of pods, and the pods are your running applications. Kubernetes, or AKS, has a built-in pod autoscaler, so it knows how to scale out instances of your pods. It also has a cluster autoscaler that adds nodes as needed. So one of the nice features of AKS is that it can scale your application automatically if you want it to. So as demand increases, it'll add pods until the node is full, and then it'll add nodes. The one additional item to note here is there's a virtual node you can use in AKS, and it uses the Azure Container Instance that was discussed earlier in this lesson. So you can sort of borrow infrastructure from Azure with Azure Container Instances, deploy some pods there, or AKS will do this while it's setting up a new node for you to use. AKS also sets up a VNet for use for your node so that they can easily talk to each other. AKS has a load balancer that's built in, so it manages incoming requests. It also has a built-in scale set, and that's how it does its auto-scaling. So you can see that AKS provides this environment made up of some other Azure resources to make it easier to deploy your containerized applications. Let me show you how to set up AKS in the Azure portal. So here I am creating a Kubernetes cluster. I will pick resource group. There's some preset cluster configurations. I'm going to change mine to a dev test, just so it'll cost less money. You need to give a cluster name, pick a region, a Kubernetes version. I'll just leave the default there. And you see that based on the preset config I chose, it's going to set up an environment where each node has 4 vCPUs and 16 gig of RAM. You can set a scale as manual or auto scale. I'll leave manual for now, and I'm going to set my node count down. Typically you would not use 1, but I'll use 1 for this demonstration. Notice I get one node pool called the agent pool. That's what's going to be my VM that's running underneath. And you can enable connection to Azure Container Instances here. Virtual machine scale sets are also enabled by default. On the Authentication tab, you can specify the authentication method for managing AKS, also the authentication method for users that are accessing nodes that are in AKS. Notice that the defaults I will leave, but there's a system assigned managed identity that Azure will set up as part of this creation, and then role-based access control is enabled by default. On the networking blade, you can see that AKS is going to set up a KubeNet, which is the network that Kubernetes uses to communicate between the nodes. It gives you a DNS prefix that's pre-filled out. You could change that if you like. And also sets up a standard load balancer. So you can see all these choices it's making because of all the other services that are going to be set up to be used as part of my Azure Kubernetes cluster. For integrations, if you wanted to integrate with an Azure Container Registry, that would provide easy access to images in the registry for use in AKS. You can turn that on if you like. And then whether you want Azure Monitor and Azure Policy used. I'll review and create. When it's finished, I'll show you some of the resources that are set up for you. Okay, my AKS is complete. I'm looking now at all the resource groups. I want to show you that I created an AKS, Azure Kubernetes Service, and you can see it here in the resource group container RG, which was my choice. AKS, as it sets itself up, also creates another resource group. This is where you find all the resources that relate to AKS. So notice in here there's a public IP address. Here's the virtual network that the nodes are running on. There's the VM scale set that's used. Inside that VM scale set would be the nodes that existed for running my AKS. There's the load balancer. So the public IP address would be hooked to the load balancer. So these resources you typically would never make changes to here. You let AKS manage these resources. But it's worth remembering that when you set up AKS, it really is just using a set of Azure services that you probably already know something about, and it's configuring those in an AKS environment. Let's go look at AKS itself, and then we'll talk a little bit about how to control it. In the Azure Kubernetes service, you'll see several blades. Some things can be changed from here. A lot of stuff you would probably just look at from here, see how your cluster is doing, see how many instances of your pods are running, things like that. Under the Kubernetes resources, you can see things like workloads, which would include applications that you want to run. AKS already has some that are running its services. You can add your own. Notice the add here, the choices here are add with YAML or add with quick start application. I'll talk about YAML briefly in a moment. The same you'll find if you go to, say, storage and you want to add a persistent volume claim, same menu choices. If you want to change some configuration or set up services, same menu choices. So control of AKS is done through a command line. As we've seen a lot with Docker, these are tools that were developed outside by third parties, Docker, Google. The command line is commonly used with tools like these to control them. It makes it frustrating if you're new to them because you don't know what the commands are. but it also means that you don't need to depend on a specific user interface if you're going to different platforms, because remember, Docker containers and Kubernetes like this are platform independent. One thing you might set up in the portal is a node pool. So the node pool is the set of VMs that are running your application. So you can add a node pool from here. You can look at existing nodes, whether they're ready, what version of Kubernetes. You can change the version of Kubernetes. You might need to do that if you're upgrading, let's say, to a newer version of Kubernetes to be used in your cluster. To finish out our discussion, let's look at how you do manage AKS. There are some things here that you should know for your exam. AKS is controlled by a command called kubectl or kubectl, K-U-B-E-C-T-L. And this is a command that Google wrote to control their Kubernetes clusters. The first thing you would need to do if you were going to use that command is install it. And so here is the Azure CLI and the PowerShell commands for installing kubectl. AZ-AKS install CLI, and the PowerShell command is install AZ-AKS kubectl. And then after that, you could run that command from PowerShell or the Azure CLI as needed. And you're not responsible for all the details of that particular command, although there's one thing that you should know, and that's that if you want to deploy an image to AKS, the kubectl apply command is the command where you specify the name of the image, and it uploads the image and loads it into your pods and runs it in your cluster. Other changes to AKS clusters are often specified in that YAML file. So YAML is just a specific text-based markup language that describes how to do deployments in AKS clusters. They're used a lot with Docker containers as well. The details of YAML commands you're not responsible for your exam. There are some options, as I showed you, that you could set in the Azure portal for managing AKS. I mentioned upgrading the version. You can scale the number of nodes in your cluster. There is support if you're deploying code or a container from outside in a registry. You can do that from the portal as well. Let's wrap up our lesson. We have talked about Docker containers and the Docker engine that must be installed on any machine that you're going to compile and build Docker containers or run Docker images. We talked about a service called the Azure Container Registry. This is a place where you can store your containers. It's private to you, it's accessible to other Azure resources. It can be convenient as a way to be able to manage your containers. We talked about the Azure Container Instance. That's a service, a platform service in Azure that allows you to run a container quickly and easily. Even the Azure Kubernetes service can use Azure Container Instance. We discussed some details of the Azure Kubernetes service, AKS. Particularly, there's the kubectl command that Google writes that is mostly the way you would manage AKS. Let's look at a few PowerShell and Azure CLI commands you might use. In PowerShell, the Kubernetes service, you can see here it's a fairly short list of commands. Here's the install, AKS kubectl, how you'd get the command line. So you could issue those commands. But here's a PowerShell command, new AZ-AKS cluster, new node pool. Beyond that, it would typically be kubectl that you would use. AZ-AKS is the Azure CLI prefix. This one does have a lot more commands that sort of cover the same things that kubectl does. I'll show you first down here's the AZ-AKS install CLI. So you need to run that so you can get kubectl installed if you want to run those commands. But then you can do some other things in here too, such as, if we look here on the right, AZ-AKS create can be used to create a cluster, and there's delete as well. There's a way to scale a cluster, AZ-AKS scale. There's not an equivalent PowerShell command for that. There's starting and stopping your cluster, running updates on your cluster, upgrading your cluster. So the Azure CLI command line has several commands that you could use from it.